Hello everyone, very good afternoon and welcome to BYJU'S Exam Prep, India's number one app for competitive exams and most comprehensive app for competitive exams, right? तो आज हम लोग डिस्कस करने वाले हैं that is analog circuits with BJT and what MOS special, and here we will cover complete BJT and complete what MOS, that is MOSFET, metal oxide semiconductor field effect transistor. Okay, right. Now there are two types of analysis, DC analysis and what AC analysis. So first of all, inform me that sound quality, picture quality, everything is fine. Yes please everyone, that sound quality, picture quality, everything is fine. Okay, okay then. Now namaste, good morning, very good afternoon Raminder Kaur, Pujita, Ayan Malik, everyone. Now all fine. Okay then. एक बार ज़रा इसे आप शेयर कर लीजिए, लिंक एक बार चैनल सब्सक्राइब कर लीजिए और इस सेशन को लाइक कर लीजिएगा. Now we are entering into what analog circuits, that is what BJT and MOS, right? BJT, according to my experience, for electrical and electronics student, biasing and stabilization of BJT, that is what cell bias circuit, collector based bias circuit, right? Diode compensation, thermistor and transistor compensation, as well as transistor compensation. These are the important topics about Q point, right? And which factors will affect the stability of Q points, that is important. Now the AC analysis means what? Small signal model. So for GATE exam, hybrid pi model and RE model is important. Hybrid pi model and RE model is important. Okay, and about what MOS, here we are discussing MOSFET. MOSFET means metal oxide semiconductor field effect transistor, right? Biasing techniques, cell bias technique in MOSFET, potential divider circuit, right? Enhancement MOSFET and DMOSFET. What is the difference between biasing techniques for DMOSFET and what? Enhancement MOSFET. And then what? AC analysis of MOSFET, that is AC analysis means low frequency analysis, mid frequency analysis and what? High frequency analysis. So there are three types of analysis, low, mid and what? High frequency analysis. तो जरा comments box में जवाब दीजिएगा. Normally we are doing which analysis, low, high or mid frequency, to get what? Again, input resistance, output resistance. Sometimes we have to find what? Norton's equivalent, Thevenin's equivalent of what? BJT as well as what? MOSFET, right? Thank you. Analog short tricks, definitely we will discuss with short tricks. I'm going to give you idea about how to solve the question within what? 1 minute on AC analysis, right? Very easy. And how we can use what? Small signal model, that is RE model and what? Pi model. Okay, sir, current mirror circuit in MOS also, definitely. धीर अब उससे भी डिस्कस करते हैं. I have some questions, I will discuss that current mirror circuit also. Now तो चलिए देखते हैं जरा. So that is my introduction. Myself Sanjay Rathi, 20 plus years of teaching experience in the field of competitive exams like ECE, GATE and PSU. Okay, and I have qualified and selected for engineering services exam multiple times. These are my ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008, and I have mentored more than 1 lakh students for these competitive exams. Okay, so important topics, right? And try to get the command over what? Simple small signal models of what? MOSFET and BJT. तो ये है theme. Second thing, these are my subjects: network, digital, control system, EDC, analog, now advanced electronics. एक important information for you, that is we have one Menti war today, right, at 9 PM for EDC and what? Analog. और मेरे साथ आएंगे रमेश सर, right, और we will discuss important numericals on basic electronics as well as what? Analog. So join that session. Okay, I am old student sir from okay then ठीक है. You are waiting for operational amplifier. Already we have discussed operational amplifier. I will send the link, right? Then that is the another session, that is Engineering Services Exam 2022 Prelims Revision Sprint, complete formula revision for analog, right? This session is also important for what GATE 2022. Here I will discuss each and every formula, right? From analog, from operational amplifier, diode circuits, then what BJT, MOSFET, feedback amplifiers, oscillators, power amplifiers, each and everything, just complete formula revision, quick revision within 1 hour 30 minutes. If we want you want quick revision, formula revision, then this is the session for you. Okay, now that is Nothing Impossible by Rakesh sir and Ankit sir, non-stop math marathon, full syllabus coverage in 2 days. तो ये देखिए 29th जनवरी एंड 30th जनवरी, तो इससे आप सब्सक्राइब कर लीजिए चैनल, सो दैट यू विल गेट द नोटिफिकेशन फॉर ऑल दिस सेशन. तो अभी आप सब्सक्राइब कर लीजिए, ये पूरे वीक आप लोगों के लिए इंपॉर्टेंट सेशंस आने वाले हैं, राइट? ओके सर, यू डिस्कस द करंट मिरर सर्किट ऑल्सो नॉट, हाँ आई विल डिस्कस आयन, डोंट वरी. देन और ये है राकेश सर अब लेने वाले हैं टिप्स एंड ट्रिक्स फॉर वर्चुअल कैलकुलेटर, राइट? हाउ टू यूज द वर्चुअल calculator during exams. This is very very important session, so simply subscribe the channel, right, and join this session. Okay, so that is a tips and tricks for virtual calculator. Now, so my dear friends, already we have covered, that is the syllabus, diode circuit, rectifiers, filter, precision rectifiers. Already I have given you the chart and some important formula, right? Now clipper and clampers, transistor biasing and stabilization, we will cover this topic. Transistor biasing and stabilization, current mirror circuit. Second thing, BJT at low frequency analysis, right? So BJT at low frequency, high frequency and mid frequency. Mid frequency analysis means we have to find the gain, AV, RI, R0, right? And then in low frequency, why there is fall in gain, and at a high frequency, what about the bandwidth, FH minus FL, right? Gain bandwidth product, that is important. Now multi-stage amplifier, just I will give you the idea about what Darlington pair, cascode amplifier, and basic diagram of cascode amplifier, right? And transconductors. Then low and high frequency analysis of FET, this is important. So we will cover this topic. Now already I have given you the idea about what oscillators, operational amplifier, waveform generator, and what linear wave shaping circuit. So that is the broad syllabus. Then first of all we will start with what, BJT. Yes Ayan, तो अरे एक बार जरा आप इसे शेयर कर लीजिए लिंक, तो और आज डिस्कस होगा पूरा BJT और what MOSFET. आपके भी दिमाग में जो भी क्वेश्चन है, यस Ayan, definitely I am going to cover what current mirror circuit also. Okay, the BJT, simple bipolar junction transistor, we have three regions, N type, P, NP and transistor. This is emitter, that is base, and that is what, collector. We are having the two junctions. This is the emitter junction, that is called collector junction, three terminals, emitter, base and what, collector. Now it is a asymmetrical device. Doping of the emitter is highest, right? Always remember, doping of the emitter is highest and area of the collector is highest. It acts as a sink, or it acts as what, source. That's why the doping is highest. Now normally that is the doping. Emitter is very very greater than NC, is just greater than NB, but it is also correct, emitter is very very greater than NB, or NB is just slightly greater than what, NC. This is the doping of the base, that is the doping of the emitter, and that is the doping of the collector, right? Area of the collector is greater than area of the emitter, is greater than what, area of the base. यहाँ जो thinnest part है, that is what, base. Okay, now very simple, PDF will be available after the class. Okay, Nusrat sir, ESE के point of view से बताएं. For engineering services exam, Nusrat, we have session from 7 PM to 8:30 PM today, right? On Hindi channel, 7 PM to what, 8:30 PM. आकाश, उसकी इंफॉर्मेशन आपको मिल जाएगी. Okay then. Now the area of the collector is greater than area of the emitter, is very greater than area of the base. So lowest area is of what? Base. So according to the concept, what about the resistance? For when we are connecting the ohmic contact across what? That is the ohmic contact. This is the for emitter, that is for what? Base, that is for what? Collector. Now what is the resistance here? Resistance is simply rho L by A. If the area is small, then what about the resistance? Give me 1 minute. Simply R is equal to what? Rho L by A. So if area is small, then resistance will be high. So base spreading resistance, that is represented by R or what? Small Rb. Is very greater than what? Re, and this is greater than what? Rc, because it has lowest area, then what? AE, then what? AC. So base spreading resistance is highest, or in model we have to consider what? Rb. So what is the value of the Rb? Everyone tell me what is the range of the Rb? That is called ohmic base spreading resistance. That is ohmic in nature. So what is the value? That is the basic question. Okay. Now then we are having the different modes, that is what? Cutoff, active, reverse active, and what? Saturation. You have idea about that. In cutoff, both the junction reverse bias. In active region, that is the forward bias, that is the reverse bias. In reverse active or inverse active mode, emitter based junction is reverse bias, collector based junction is forward bias. This is rarely used configuration. Rarely used configuration. Right. And then what? Saturation, that is both the junction forward bias, and it is used, cutoff and saturation is used for what? Switching action. तो ये है. No, I am not going to cover the complete syllabus. I am just Sahil. Today I will cover what? BJT and MOSFET, because this is a BJT and what? MOSFET only. Okay. Around 40 to 400 ohms. Yes, Bhai Reddy, that is your right answer. Normally this is the range of the base spreading resistance is what? 40 to 400 ohm. And emitter resistance and collector resistance is very small, that is what? 10 to 25 ohm. So we can neglect the emitter and what? Collector ohmic resistance, but we can't neglect what? Base spreading resistance, and typical value is what? 100 ohm. If it is nothing is given, then you can use 100 ohms. Right. I am talking about the just ohmic resistance. Ohmic resistance means when we are connecting voltage across this, there will be a loss. There will be a loss of the voltage. Simply voltage drop across this ohmic contact. Okay. So I am talking about the ohmic resistance because of this connection. Now, so that is the basic question. Now the common base configuration. Now we are having the three configuration. That is what? One is the common base. Second configuration is what? Common emitter. Third configuration is what? Common collector. Right? The common base configuration. What are the properties of the common base configuration? Very simple properties of the common base. So watch this diagram. We are giving input to the emitter. We are getting the output from the collector, and that is what? Base. Base is common. Now here we are giving the input. This is called constant current characteristics. What is this? Constant current characteristics. Right? Current controlled current source. Constant current characteristics for common base. Right? Now, rarely used configuration, that is the common base. Second thing, it has highest output resistance but lowest input resistance, and voltage gain is highest for this. Okay. Which one is the most popularly used configuration? जहां से आप लोग normally we are expecting the question from that configuration. Yes, please. कौन सा ऐसा है जहां से आप लोग क्वेश्चन एक्सपेक्ट करते हो कि यस यहां से क्वेश्चन आएंगे? So, but there may be a question from what common base configuration, there may be a question from what common collector, that is also called emitter follower. So in case of common base configuration, what are the properties? It has the lowest input resistance, highest output resistance, lowest current gain, that is alpha less than 1, highest voltage gain, phase shift is 0, and that's why we are using the common base as what? Non-inverting voltage amplifier. Non-inverting voltage amplifier. Right? This is the clear one. Now the common base amplifier will offer largest bandwidth and it is more suitable for high frequency application. So we are talking about the gain bandwidth product. Gain bandwidth product, GBW. This is nothing but current gain into bandwidth in case of BJT, because it is a current control device. So current gain is lowest. Current gain is lowest, and that's why bandwidth is highest. Bandwidth is highest. So during high frequency analysis of BJT, I will give you the formula and one diagram. Single diagram, 4 formula, you will be able to solve all the questions from high frequency analysis of what? BJT. So this is the gain bandwidth product. Since the gain is the lowest and that's why the bandwidth is the highest, this is a figure of merit. It is a constant for any amplifier. When we are getting the bandwidth highest, it means we can use the common base amplifier for high frequency analysis. Very simple concept. Now that is a common emitter configuration. Here input is given to what? Common base, output from the common collector, right? This is the collector, and common terminal is what? Emitter. Emitter is connected to ground. Input is given to base, output from the collector, and emitter is connected to ground. This is what? Simply common emitter configuration, most popularly used. What about the properties? Input resistance moderate, output resistance moderate, voltage gain high, current gain just moderate or high, but the power gain is the highest one. Power gain is the highest one. So what is the Dheer sir? I always confuse in this gain bandwidth में current gain bandwidth and voltage. देखो actually क्या होता है that BJT is what? Current control device, and that's why initially we are calculating the current gain into bandwidth product. And what about the FET? Current control device or voltage control device? Yes Dheer, BJT is a current control device. तो देखिए इसका जो है ना, that is the phase shift is what? 180 degree, and most common and very popularly used configuration. Most common and very popularly used configuration. Just now, this is very important question on common emitter configuration. Everyone, that is the diagram. Just I am giving you one question. This is the 5 volt, 50 kilo ohm, 3 kilo ohm, that is the 10 volt. This terminal is called C and this is the E. Very, very simple question on biasing C and E, right? Then C terminal, collector and emitter terminal, VBE is given as 0.7 volt, right? VCE set is given as 0.2 volt, right? VBE set is given as 0.8 volt and beta is given as 100. ICO negligible. देखो general question, I am giving you the general question. ICO is negligible. Now what is the value of the IC? Everyone find IC. So this is very, very basic question from common emitter configuration, and that is related to what? Biasing. So it is biased in active region or cutoff region or saturation. First of all, we have to decide this, right? How FET develop high frequency at what? What is the Siva Prasad? What is this question? Please elaborate this. What you want? Yes, FET is what? Basically a voltage control device. अरे एक बार जरा इसे शेयर कर लीजिए ताकि स्टूडेंट्स को आप बोलिए ज्वाइन कर लें. Within 3 to 4 hours, we will cover BJT and what? MOSFET, biasing, stabilization, and what? AC analysis. Right? AC analysis means high frequency, low frequency, mid frequency, Norton's equivalent, Thevenin's equivalent. This type of questions in GATE 2022. Okay. Okay. So here one student give the answer, that is what, 3.26. So what about the transistor, whether it is in saturation region or in what, cutoff region or in active region? First of all, we have to decide. First, saturation, cutoff or active region. So number of questions on this topic, active region, right? Now please try to understand this question. Here VBE is given as what? VBE is given as 0.7 volt. This is called VBE, between base and what? Emitter. But this value is for what? Active region. If it is in saturation, then the value you can choose what? 0.8 volt. But normally in GATE exam, VBE active and VBE set are what? Equal. VBE active and VBE set are equal. Everyone please give me the answer. So normally in GATE exam, if nothing is given, to VBE active and VBE set we can use. If only one value is given, that is a VBE. If it is given as 0.7 volt, you have to use 0.7 volt. If it is given 0.6 volt, then you can use what? 0.6 volt. Okay. Now in next session, Manish Sutradhar, I will arrange extra sessions to cover what? Rectifier and filters. In evening, we will discuss each and everything from 7 to 8:30 p.m. Okay. Please note the time on Hindi channel, 7 to 8:30 p.m. Now VBE active and VBE set, that is what? 0.7 volt, right? If it is given, then you have to use this value. Now sometimes in GATE exam, VCE set, if VCE set is given as 0.5 volt, so what about this 0.2 volt? 0.2 volt is what? Typical value. 0.2 volt is a typical value. If in particular numerical nothing is given, then you can use 0.2 volt. But if 0.5 volt is given, then you have to use what? 0.5 volt, right? Otherwise you will get the wrong answer. Now try to understand. In this case, it may be in active region, it may be in saturation. So first of all, always remember, if we are assuming that let it is in what? Active region, then all values are given. Find IB. What is the IB? IB is equal to 5 minus 0.7 divided by what? 50 kilo ohm. Normally students are doing this active. Let I am assuming that active region, right? But first of all, start with this, whether it is in cutoff, yes or no. So it is not in cutoff because this junction is what? Forward bias. 5 volt will make it forward bias, that's why it is not in cutoff. Let it is in active region. So 5 minus 0.7, that is the 4.3 divided by 50. This is the in milliampere. This is the value of the base current. Now what is the IC? IC is equal to beta IB plus 1 plus beta times of ICO. So what about the reverse saturation current? Negligible, neglected. So what is the IC? Beta 100 into 4.3 divided by what? 50. Now multiply it and you will get the answer 8.6 milliampere. 8.6 milliampere. Now today Rakesh sir will give you the idea about the virtual calculator, but my dear friends, normally students will first of all convert this 4.3 divided by 50. They will calculate this value and then what? They will multiply with the 100. Just simply we are wasting our time. 0.086 milliampere, then multiplied with the 100 and 8.6 milliampere directly. No need to calculate this value. Okay. To avoid this type of calculation, directly 50 divided by 2, that is what 2 multiplied, and you will get the 8.6 milliampere. But always remember, some students gave the answer 8.6 milliampere. That is the wrong answer because we have to calculate what? VCE. What is the VCE? VCC minus IC into RC. 10 minus what is the IC? 8.6 into what? 3. No need to calculate this value. because this term is greater than what 10, and that's why this value is less than what 0.2 volt. If this value is less than 0.2 volt, it is in active region. It is not in active region. It is in saturation region. Finished? Always remember, after calculating the current, you have to calculate what? VCE. Then it is in saturation directly. What is the method then? Then simply, so everyone, please give me what is the value of the overdrive factor? What is the value of the overdrive factor? ये देखो, ये तो आपका आ जाता है गलत, इसलिए देखो ये दिस इज अ वेरी सिंपल एंड कॉन्सेप्चुअल टॉपिक ऑन कॉन्सेप्चुअल न्यूमेरिकल ऑन व्हाट? बाइसिंग. On biasing. Now this transistor is in saturation. Always remember this value is constant for saturation, VCE set, and this value is also constant, that is called VBE set. Directly you can calculate the IC. IC is equal to 10 minus 0.2 volt divided by what? 3 kilo ohm. 10 minus 0.2 divided by what? 3 kilo ohm. That is nothing but 9.8 divided by 3. Nearly equal to this. 3.27 milliampere is the right answer for this question. Okay, that is the way how we can calculate. Second thing, if your overdrive factor is required, then you have to calculate IC minimum, IB minimum. What is the IB minimum? IC set divided by what? Beta. IC set divided by beta, that is the 3.27 divided by what? 100. 0.0327. And then you have to calculate what IB here. What is the actual IB here? So IB is equal to 5 minus 0.8, because VB set is 0.8 divided by what? 50. 0.084 milliampere. Okay, this is called IB, and if this IB is greater than IB minimum, that means it is in saturation. So IB minimum is the minimum base current required for the saturation, and this calculated IB is greater than IB minimum. And what is the overdrive factor? आपने आंसर नहीं दिया भाई अभी तक. What is the overdrive factor? It is in oversaturation. Oversaturation means IB divided by IB minimum. You will get the answer 2.5 something. IB divided by what? IB minimum. This is called what? Overdrive factor. So that is very important questions. Everything here it is covered. What is the overdrive factor? How we can calculate the IC if it is in saturation, and then that is the value. Okay, it is clear to you everyone? Yes, overdrive factor means what? Oversaturation. Here we are talking about the oversaturation. Means what is the current required here? Only 0.0327 for saturation, but here we are providing 0.084, means it is higher than what? This value. So what about the factor? It is higher by what? 2.5, nearly 2.5. That is called overdrive factor. Okay, ये हो गया. और इस डायग्राम को याद रखिए. लास्ट वन, ये देखिए. This is the diagram. This is IC set. IC set, and this is the IB minimum. If the IB is greater than this is the IB, and this is IC. Finished. So that is, here the IC is equal to what? Beta IB. It means it is in active region, and that is what? Saturation region. Saturation. Now another question, just I will discuss another question. Yes. Now another question on this biasing. Very general question on biasing. What is the name of this biasing, everyone? What is the name of this biasing? This is VCC, this is R1, that is R2. Right? This is RC, this is RE, this is R1, and that is what? R2. And you have to calculate what? IC or IB. So normally question is given, calculate the IC or calculate the VCE or calculate the voltage across the collector terminal or calculate the voltage across the emitter terminal. This type of questions. Okay, so first just I am giving you the types of question. Calculate what? IC, VCE, VC, V, right? And so these are the values. Next thing is what? Normally in this type of questions, particularly it is given that beta is very, very large. Beta very, very large. If the beta is very, very large, if it is given in particular question, beta is very, very large, if it is given in the particular question, then simply base current is negligible. You can take the base current is nearly equal to what? 0. Nearly equal to 0. If beta is given in particular question, then you have to consider it. Otherwise, base current is what? 0. Collector current is nearly equal to what? Emitter current. IC is equal to what? IE. So always remember, this is the standard diagram, and here this circuit is called potential divider circuit. Potential divider biasing. Right? This is the potential divider. Second thing, here I am connecting a RE. This is called feedback element. Here we are getting the feedback. This is the self-biased circuit. Self-biased circuit. Number of questions on this topic. This is a voltage divider or potential divider or self-biased circuit. Right? These are the name of this particular circuit. Now, here I have to use what? Potential divider to find the value of IC or to find the value of VC or what V. We are using this method, potential divider here. Right? Now, potential divider means this is the point R1, R2, that is the VCC. Simply find the value of voltage at this point. What is the voltage at this point? R2 by R1 plus R2 into what? VCC, and that is called what? VTH. And when I am finding the resistance across this terminal, this is connected to base, so RTH is given by R1 parallel with R2. Always remember, if the beta is very, very large, then no need to calculate what? RTH. No need to calculate the RTH. Directly you can solve this question. Now, once you find the value, then directly use this diagram, that is RTH, VTH, connect BJT with RE, and here it is RC. RC, and this is what? RTH, and this is VTH. Sometimes we are directly getting this type of questions. So this is a RE. Right. Now it is very, very easy one. Here it is a IC. Always remember that is IC. This is IB, and this is IC plus IB, and this is called VBE. This is called what? VBE. So electrical students, this is a very general question for your 2 marks question. ओके, चलिए अब देखते हैं. देखो, अब यहां पर पॉइंट आएगा RTH, RC और RE. तो राइट, इफ इट इज इन एक्टिव रीजन, then you can say IC is equal to what? Beta IB. Beta IB. So what is the IC plus IB? Always remember this. IC plus IB will become 1 plus beta times of what? IB. Use this formula, directly write down the KVL. This will become VTH is equal to what? IB into RTH plus 1 plus beta times of IB into RE. You have to replace this IC plus IB is equal to what? 1 plus beta times of IB into RE plus what? VB. Plus what? VB. So everyone please remember this formula because it is a very general diagram. What is the IB here? Directly you can calculate the IB, VTH minus VB divided by this resistor RTH plus what? 1 plus beta times of what? RE. 1 plus beta times of RE. Remember this formula. Directly remember this formula. This is very important one. अब देखो, we have limited time, so directly we have to use this formula, that is IB is equal to VTH minus VB upon RTH plus 1 plus beta RE, and directly you can calculate the value of what? IB. Once you will get the value of IB, then simply you can find the value of IC and directly find the value of VC. That is the question. How we can find the value of VC? Write down the KVL, sorry. So VCS is equal to IC RC plus what? VC plus what? 1 plus beta times of what? IB into RE. So from this formula we have the value of the IC, we have the value of the IB, then you can find the value of what? VCE. Sometimes VC is asked here. Please read question carefully. If only VC is asked here, you can find VCC minus IC into RC. VCC minus IC into what? RC. So that is the way. Any doubt in this question? Any doubt in this particular question? Anybody? Right. So that is the normal question in active region. 99% chance it will be in active region because of this RE. RTH, that is the VB. Write down the KVL here, write down the value here, and then you can find the values. Right. Now, if beta is not given, beta is very large, then simply neglect IB, and then you can find the value of IC directly. Then what is the drop across the RTH? It will become 0, and this term, directly watch this diagram, and directly this term IC plus IB is replaced by what? IC. Write down the KVL and you can find the value. So beta large. What is the VTH is equal to? Beta is very large. No need to calculate the RTH is equal to VB plus IC into what? RE. So what is the value of the IC or IE? Both are equal. VTH minus VB divided by what? RE. VTH minus VB divided by what? RE. Directly you can find this value. So number of students using what? RE plus RTH. No need to find the RTH here, right? If the beta is very large. Now, ये हुआ एक question on that is what? Self bias circuit. How to find the IC, how to find the value of the VC. These points are called Q points. These points are called what? Q points, operating points. Now next one, next question we are getting on this diagram. What is the name of this diagram? This is connected here. RC and RB, this VC is required here. That is the question. Very simple one. Standard diagram on BJT. So what is the name of this biasing? So देखिए जरा, the name of this biasing is what? Here it is RC, here it is RB, and that is what? VCC. Now simply this is the collector and that is what? Base. collector is connected to base. So what is the name of this diagram? Simply it is a collector base biasing. Collector base biasing. Don't know, Prakhar, what is your question, sir? For the PNP transistor condition for the region of the operation will same as everything will remain same, but you have to change the polarity of the voltage. Polarity of the voltage. I will discuss one question from what? PNP transistor. Don't worry. Sri, sir, what is the minimum value of the beta we can consider in numerical? It may be what, 25, sometimes it is 30 is given, right? But for amplification, the normal range of the beta is what? 50 to 150. 50 to 150. And for current mirror circuit, when we want to design the current mirror circuit, the beta should be as large as up to 1000. 1000 beta is required for current mirror circuit. So this is the collector to base bias circuit. So what is the normal numerical? Numerical is what? Simply beta is given, right? Beta is given, VB is given, and then you have to find what VC. That will be the question. That will be the question. So always remember, general mistake. This is the VB. This is what IB. Always remember, this is the IB and that is the IC. So what is the current here? The current here is not IC. Number of students making this mistake. They are taking IC here, but here it is IC plus IB. IC plus IB. Second mistake. It may be in saturation, it may be in cutoff, it may be in active region. No. It is in what? Active region. Why? Once the collector is connected to base, what about this voltage? Everyone please give me the answer for this question. Plus, minus. This is what? VCE. Plus, minus VCE. So it is in active region means when I am writing the KVL from this point to this point, this is the IB. This is IB. Right? So VCE is equal to IB into RB plus what? VBE. IB into RB plus what? VBE. So VBE is what? 0.7 volt, and that is the right direction of the IB. So this is the plus and that is the minus. This is the positive value, and VB is 0.7 volt. Definitely it is greater than what? 0.2 volt. It means it is in what? Active region. It is in active region. So always remember, if the collector and base, there is one resistor or it may be short circuit. Collector is connected to what? Base via one resistor or directly short circuit. It will be in which region? Active region. So ये है active region. No need to verify it. No need to verify it. That is the reason. Okay, no need to verify. And directly, if it is in active region, always remember IC plus IB is equal to what? 1 plus beta times of what? IB. 1 plus beta times of IB. Directly use the KVL from this point to this point. Never use the KVL from this point because we have no idea about the VCE. So this is the path. Write down the KVL and directly VCC is equal to 1 plus beta times of IB into RC, this is called RC, plus IB into RB plus VB. In question, the value of the VB is given to you, then RC, then what? Beta, and you can find the value of IB, then what? IC. What is the IC? Beta IB. Right? Now, if the value of VC is required, in this case VC and VCE are equal, the value of VC is required, then you can directly write the VC, or that is equal to VC in this case is equal to VCC minus ICRC, IC plus IB into RC. So normally students are making mistake here. This is the drop across the RC is not ICRC, this is the IC plus IB into RC. Use this formula. Any doubt up to this point? Any doubt up to this point? Yes, we can say, sir, same like the diode connected transistor. Sir, if they change the VCC, then it might go to, if they are not providing the sufficient VCC. Sufficient VCC means what? Only 1 volt is given, right? Then definitely only 0.7 volt is given, then definitely it will goes into what? Cutoff region. Emitter resistance, and it is possible that it may be in saturation. No, Prakhar, just I will cover this. So this is all about this diagram. What is the question? How we can write the equation IC plus IB, and that is what IB, and again here this is the branch, here the current is what IC plus IB, but we are not having any resistor here. So if the collector is connected to base, that will be the condition. It may be in cutoff, or it may be in what? Active region, not in saturation region, not in saturation region. Now next question, if I am connecting RE here, what will happen? Just RE is connected here, no need to worry. This will become what? IC plus IB again, but this KVL will remain same. This KVL will remain same, means again it is in what? Active region. VCE is equal to what? IB into RB plus what? VB. Here we are moving from this point. This is the VC, this is the VB. We are writing the KVL. VCE is equal to IB into RB plus what? VBE. So that is greater than what? 0.2 volt. Okay. Okay, Prakhar. If the RE is connected, again it will be in what? Active region. Again it will be in active region. Now what is the role of the RE? You have to write the equation. There is a change in the equation. The VCC is equal to 1 plus beta times of IB into what? RE? RC plus what? 1 plus beta times of IB into RC plus IB into RB plus what? VB plus what? 1 plus beta times of IB into what? RE. You have to add this term, extra term, 1 plus beta, because IC plus IB is replaced by what? 1 plus beta times of IB. This is replaced by 1 plus beta times of IB. Now write down the equation from this point to this point and get the value of the IB, and from IB you can find the IC. I think now it is clear to you, everyone. Now what is the silly mistake, general mistake? If now VC is required, student will directly write VCC minus IC plus IB into RC. If VC is required, my dear students, this is the voltage between emitter and collector, collector and emitter. So always write the KVL from this point to this point if VCE is required. Always remember, what is the KVL? VCC is equal to 1 plus beta times of IB into RC plus VCE plus 1 plus beta times of IB into what? RE. Now from this point you can find the value of the VCE, from this point to this point. So normally students are writing like this: VCE is equal to what? VCC minus IC plus IB into what? RC. Or some students are writing VCC minus what? ICRC only, ICRC. So that is wrong. This is not with respect to ground. This is the between what? Collector and emitter. If only VC is required, if VC is required, then it is right. So this is not VC, this is what? VC with respect to ground, with respect to ground. I think now these two concepts are clear. That is all about this particular question. This is very important one, right? So here the supply voltage is given, the VCC. If this VCC is very small, then it may goes into what? Cutoff. But if it is normally, it is given as what? 10 volt or 20 volt. So that is connected here. Okay. And because of this, there will be a current, and this current will drive the transistor in what? Active region. Drive the transistor in active region. Okay. Any doubt? Okay then, 1 minute here, थोड़ा स्पैम होने लगे फिर से. ओके देन अब आता देखो टू टाइप्स ऑफ क्वेश्चन हो गए दैट इज व्हाट वन क्वेश्चन ऑन सेल बायस सर्किट अनदर क्वेश्चन ऑन व्हाट कलेक्टर बेस्ड बायस सर्किट दिस टाइप ऑफ क्वेश्चन नेक्स्ट वन नेक्स्ट questions on what stability factor the Q point means what quotient point it is affected due to तो आंसर दीजिए थोड़ा कमेंट्स बॉक्स में Q point stability is affected why the Q point stability is affected everyone so Q point stability means what we have the formula IC is equal to beta IB plus 1 plus beta times of ICO, right? And there is a ICO, it doubles for every 10 degree rise in temperature. It doubles for every 10 degree rise in temperature, and definitely it will affect the value of what IC. Beta is affected because of the temperature, but the effect of temperature is negligible. Beta is mainly affected due to replacement of transistor. And third thing is what VBE, base to emitter voltage, VBE. It is affected if this is the what is the temperature, effect of temperature dVB by dt. It is negative 2.0 millivolt per degree centigrade, right? In some textbook it is given, as minus 2.5 millivolt per degree centigrade. That is the value. So but it is negative. Temperature increases, VBE decreases. So that is the case. तो ये है point. अब point देखिएगा जरा. Stability factor means ratio. S is equal to change in IC because of the change in ICO. When beta VB kept constant, these are constant. Just I want to ask very simple question on S. What is this? Negative or positive? So this there may be a question on what MSQ. Then what S dash? Change in IC because of what? Change in VBE. Change in VBE. IC and ICO and what? Beta kept constant. S double dash. Change in IC because of change in beta. Beta and VBE kept constant. VBE kept constant. Okay, so these are the three factors. Now because of the temperature, ICO is affected, VBE is affected, but the effect of the temperature on beta is negligible. Beta is highly affected due to the replacement of the transistor, right? Normally we are getting the question to find what value of S. Value of S. What is the value of S for self-bias circuit? That is the self-bias circuit. We are having the RC, RE and what RTH. For this particular diagram, self-bias circuit, what is the stability factor S? Yes, please tell me what is the stability factor S for this self-bias circuit? क्या होगा भाई बताइए जरा. देखिए बहुत सारे हमने क्वेश्चंस डिस्कस किए हैं, अब ध्यान रखना है आपको. यस, तो दैट इज 1 प्लस S is positive, right? 1 plus RTH by RE. That is the approximate formula for stability factor. 1 plus RTH by RE. Okay. That is the stability factor for this diagram. So that is, this will be the question, but there may be another question. Yes, during calculation of S we have to kept VBE and what ICO constant. right? Simply keep these values VB and ICO, VB and beta will constant. For S dash, ICO and beta is constant. This is also called SV, and that is the S double dash or S beta. Change in IC because of change in beta, where ICO and VBE kept constant. Where ICO and VBE kept constant. Please correct it. No problem. So this S is what always positive. This is what negative, and that is what positive. That is what positive. So positive, negative, and what positive. So these are the values. Remember this. Positive, negative, and what positive. Now, how many students are able to find the S dash for this diagram? How many students are able to find the S dash for this diagram? They may ask question on what S dash. Find the S dash, value of the S dash. So always remember, right? If S dash is required, then write the equation here. Write the equation here. That is what simply, first of all, get the Thevenin's equivalent. That is the self-biased circuit. Then write down one equation here, that is what VTH is equal to IB into what RTH plus what VB plus this IC plus IB. We can write the IC plus IB is equal to IC plus IB into what RE. IC plus IB into what? RE. And always use one equation, that is called IC is equal to what? Beta IB plus 1 plus beta times of what? ICO. Only two equations. Only two equations. Okay. आप अपने क्वेश्चंस रख सकते हैं. It is a quick revision. I am just giving you the idea of which type of questions they may ask from what biasing and stabilization. Simply we are discussing the question. Okay, let them laugh. जिसको भी नया लग रहा है तो वो थोड़ा सा ध्यान दीजिए, because only we have only what, I think only 10 days for exam, 10 to 13 days for our GATE exam. Okay. So 10 to 13 days means what? Quick revision of cell bias circuit, collector based bias circuit, or what biasing and stabilization technique, which type of questions they may ask, and that is what? That is the reason. So sometimes normally they will ask what S, what is the S factor? So S is what? 1 plus RTH by RE. And what is the value of the S? The range of the S is the 1 to what? 1 plus beta. That is the range of the S. But they may ask S dash. So what is the S dash? Change in IC because of what? Change in beta, VB. Beta and ICO kept constant. Beta and ICO kept constant. If this is the question, try to understand this concept. If this is the question, my dear friends, first of all, get the IB in terms of IC, get the IB in terms of IC, replace the IB in terms of what? IC and ICO, and then differentiate it with respect to what? VBE. Differentiate the particular equation with respect to what? VBE, keeping beta and ICO constant. When we are keeping the beta and ICO constant, everything will be cancelled, and then you will get S dash. If that is the question, just I am giving you the hint how we can solve this type of questions. So in coming exams they may ask, is it possible? Because that is in syllabus. So normally we are reading the question on this, but that is the important point. Another important point. So find the IB in terms of IC and ICO, put in this equation. Then you will get the equation in terms of what? VBE, IC, beta and ICO. Differentiate with respect to VBE. All the constant term differentiation will be 0. VTH, differentiation of VTH will be 0. Right? And beta and ICO is constant. And finally you will get the value DIC by DVB. One precaution. It will be what? Negative value. It will be what? Negative value. Right? So always remember this is the negative. IC is equal to IB. Now IC is equal to what? Beta IB plus 1 plus beta times of ICO. That is the equation in active region. दिस इज इन एक्टिव रीजन, ये यूज कीजिए एंड देन यू कैन फाइंड द वैल्यू। ओके, अब आती है बात, अब हम लोग तो देखो अभी मैंने आपको कुछ बताया कि सेल्फ बायस में किस तरीके से क्वेश्चंस आ सकते हैं। नाउ देखिए, मैं कुछ क्वेश्चंस आपको बता दूं, ऑलरेडी एग्जाम में आए हुए, आप बताइए व्हाट इज द आंसर फॉर दिस क्वेश्चन। देखिए, for the circuit shown in the figure, that is the same diagram, this is the 4R, this is the RB, this is the beta is 29 and that is the R. For the circuit shown in the figure below, it is given that VCE is equal to VCC by 2. Simply they will change the data or they will change the just slight change in the question, but the diagram will remain same. Collector base bias circuit with R, that is called RE. Collector is connected to what? Base with R. This is the 4R, that is the R, beta is 29. For the circuit shown in the figure below, it is given that VCE is equal to VCC by 2. The transistor has beta 29, VB 0.7. When the base emitter junction is forward biased, for this circuit the value of RB by R. You have to find the value of RB by R. Everyone give me the answer. Already I have discussed the method for this particular question. Right. What is the RB by R? Yes, please. Sir, material science electrical gate syllabus में आता है. I think the syllabus change. Check the syllabus. It is available to you. But material science we are not having. In evening classes, I will discuss that because it is related to what basic electronics. अब देखिए जरा, ये है क्वेश्चन. इस क्वेश्चन में सिंपली this value is what 0.7 volt. It is given as VBE. That is what 0.7 volt. Already I have given, this is nothing but VCC by 2. From this point to this point, it is the VCC by 2. What is the VCC by 2? 5 volt. Now you can write what is the current here. This current is what? IC plus IB. This current is IC plus IB. And here again it is the IC plus IB. Here it is what? IC. IB. Okay. Then you can write one equation here. And you can write one KVL here and you will get the ratio. You will get the ratio. That is very simple question. What is the answer for this question? Write one KVL. Already I have given you the KVL. What is the VCE is equal to IB into RE plus VB. So you can write the 5 is equal to, because the VCC by 2 is nothing but 5. That is given in the question. Is equal to IB RB. IB RB plus what? 0.7. You can say IB into RB is equal to 4.3 volt. That is the equation number 1. Second equation directly you can, this is the IC plus IB is nothing but 1 plus beta times of IB. Always remember 1 plus beta times of IB. Then you can write 10 is equal to 1 plus beta. What is the value of the beta? 29. 30 times of IB into what? 4R. Directly you can write 30 times of IB into what? 4R plus 5 plus this is again 30 times of IB into R. IB into R. So what is this? 10. This is the 5 is equal to 30 into 120 plus 30, 150 IB into what? R. Now divide these two equation. Divide these two equation. IB will cancel and then you can find the ratio of what? RB by R. Yes. Now it is over. IB R. Right? What is the answer? 129. So देखो ये है question. Again it is based on what? Collector based biasing. You have to write the 2 KVL, 1 KVL from this point to this point and 1 KVL from this point to this point. IB cancel and you will get the ratio of RB by R. Please arrange this and get the proper answer. Okay, please avoid the silly mistakes. Okay, this type of questions. Next one, on biasing. Now another question, consider the NPN transistor. Consider the NPN transistor. IC plus IB is equal to 1 plus beta times of I. Why we can't write? While calculating the S dash, IC plus IB. Oh, no, dheer, because we want, that is your question. Please, everyone try to solve this question. In IC plus IB, why we are not writing 1 plus beta times of IB? Because we want DIC by DVB. We have to replace the beta. And here, second important thing about that, when we are finding, we are not neglecting the ICO. We are not neglecting the ICO. We are keeping the ICO constant, but we are not neglecting. That is the case. Everyone, please try to focus on this. Always remember, during finding S dash, S double dash, transistor is in active region and we are using this formula and one equation from the given diagram. But during solving numerical, we are neglecting this one. And that's why we are using what IC is equal to beta IB only. And then we can write IC plus IB is equal to what? 1 plus beta IB. But during solving this, we are not neglecting, then we have to consider. Okay, so here now it is clear to you. You can't write like that. IC plus IB is equal to 1 plus beta IB during IC. Right. Okay. During finding what? S dash, S double dash. तो आप इसको मत रखिए, ये वाला यूज कीजिए. ये तो होता है न्यूमेरिकल बनाते समय इसको यूज करते हैं क्योंकि आईसीओ को नेग्लेक्ट कर देते हैं हम लोग. बताइए व्हाट इज द आंसर फॉर दिस क्वेश्चन. ओके, देखिए जरा इस क्वेश्चन में ना आपका आंसर जो है, देखो यहां पर क्या मिस्टेक करते हैं बच्चे. अगर इस क्वेश्चन को बनाना है तो पॉइंट ध्यान दीजिएगा. हमको बनाना है, मान लीजिए ये यहां पर, दैट इज व्हाट, यहां इस पॉइंट पर एक केसीएल लगाया जा सकता है. देखो कई स्टूडेंट्स इस पर गलती कर देते हैं, तो मैं आपको बता दूं, ये जो करंट है ना, ये जो करंट है आपका आ रहा है, 1 मिनट, गौरव सर इन क्लास. देखिए दिस इज द आईसी, this is the IC. Current entered through the terminal. This is the IC, this is the IE, and this current is what IB. This current is IB, and this drop is what 0.7 volt. Now here to find the value of the V0, we can apply the KCL, nodal analysis at this point. But always remember, first of all find the value of the IB. IB is equal to 5 minus 0.7 divided by 1 mega ohm. To convert this resistor in kilo ohm, that is the 10 to the power 3 kilo ohm. That is become 10 to the power 3 kilo ohm. It will be 4.3 into 10 raised to power minus 3 milliampere. This is the value of IB. What is the value of the IC here? IC is equal to beta IB. It is multiplied with the 100 because HF is nothing but beta. It will become 0.43 milliampere. That is the value of the IC. That is the value of what? IC. Now write down the KCL at this point. What is the KCL? V0 minus 12. V0 minus 12 divided by 2 plus V0 minus 0 divided by 4 plus what is the outgoing current? IC. Put the value IC 0.43 is equal to what? 0, and then you can find the value of V0. Nearly equal to 7.43 volts something. You can calculate it. So this type of questions, no, it is not always fixed, but if nothing is given then you can use. Okay. हाँ विशाल त्यागी, ये भी अब मैकाट्रॉनिक्स और रोबोटिक्स। चलिए आप नया चैलेंज दे रहे हैं तो पढ़ना और पढ़ाना ही तो हमारा काम है। एक टीचर का क्या काम होता है? टीचर का काम है R&D करना, बच्चों की डिमांड के हिसाब से चलना, कुछ नए नए कॉन्सेप्ट आपको देना और इजी करना टॉपिक्स को, ताकि बच्चे समझ सकें। राइट, तो ठीक है, इसके बारे में भी अपन लोग डिस्कस करेंगे। हो गया, ये होता है एक अलग टाइप का जो क्वेश्चन है, इसको भी बोलते हैं बाइसिंग। कैसे आपने कनेक्शन किया हुआ है, तो और ये HFE जो होता है दैट इज कॉल्ड व्हाट? बीटा। DC बीटा is represented by what? Capital HFE. Sometimes it is also represented as DC beta. This is all HFE and so on. The answer is what? D, 7.5 volt. Okay, now number of questions, और ये देखो एक और ये नया क्वेश्चन जो आता है, ये भी इंपॉर्टेंट क्वेश्चन है जो गेट एग्जाम में ही आया हुआ है। व्हाट इज द आंसर फॉर दिस पर्टिकुलर क्वेश्चन एवरीवन? देखो फिर से है बाइसिंग एंड स्टेबलाइजेशन पर, लेकिन देखिए आपको लगेगा वी आर टेकिंग द आउटपुट फ्रॉम व्हाट? कलेक्टर, सॉरी एमिटर। दिस इज द कलेक्टर। So when I am taking the output from emitter and input is given to base, so first of all give me the name of the configuration, whether it is a common emitter, common collector or common base. Everyone, common emitter, common collector or common base. This type of questions are very general. Where is the Q point is placed? सर इस क्वेश्चन में चेक करने की जरूरत नहीं है whether it is a saturation or active region. In which case प्रखर? In previous question. In previous question we are getting what? 7.4. No need to calculate. Why? Because in previous question if I am getting the 7.4 volt, so 7.4 volt, that is nothing the value of what? VCE, or this is greater than what? 0.2 volt. No need to calculate. No need to calculate in previous question. Okay, now 7.4 volt is greater than 0.2 volt. Now watch this. Common collector configuration. That common collector is also called emitter follower. Emitter follower. What is the question for the common collector configuration? It is written here, shown in the figure. The BJT has high beta. Beta is very very large. Then we can neglect what? Base current. Negligible VC is set. Then you have to take what? 0.0 volt. You have to take 0.0 volt. VB 0.7 volt, the maximum undistorted peak to peak output voltage. That is the question from GATE exam and electrical branch. तो थोड़ा इलेक्ट्रिकल वाले भी थोड़ा सा समझ लीजिए. Okay, now how we can solve? This is on based on what? Biasing. Again biasing. So biasing means what? Where is the Q point is located and what we are getting the maximum undistorted peak to peak output voltage. Here we are getting the output. Here it is called coupling capacitor CC2. This is called coupling capacitor CC1. We are connecting here. What should be the value of the CC1 and CC2? Large or small? Tell me. What is the CC1 and CC2? It should be large, small or moderate. क्या होना चाहिए? Values. Now during DC analysis, this capacitor will act as open circuit. You have to apply what? Thevenin's across 5 and 10. So what is the Thevenin's voltage? That is nothing but 10 divided by 5 plus 10 into what? 12 volt. Okay, then you will get 8 volt. RTH, no need to calculate RTH. Why? Because the beta is very very large. We are just simply wasting our time. 5 parallel with the 10. This is the waste of time. Kilo ohm. Okay, third thing, once you will get the value of this, during DC analysis this capacitor and this capacitor will act as open circuit. Right, both the capacitor will act as open circuit. Simply No need to find the value of RTH. This is, you have the value of 8 volt. What is the DC output here without capacitor? Right, this voltage is what? 0.7 volt. What is the drop across the RTH? 0. Why? Because IB is 0. Beta is very, very large. That is the 12 volt. So DC output. What is the DC output? 8 minus 0.7, that is nothing but 7.3 volt. 7.3 volt DC output. Right? It should be large. Right? Just I will give the answer for this question. Yes, Kishan given the answer 9.4 volt. And Sohail is given 9.4 volt. Yes, that is the right answer. Okay. Now, in this question, first of all, remove the capacitor and find the DC voltage. So DC voltage is what? 7.3 voltage. Second, always two extreme cases, cutoff. Cutoff means this transistor will act as open circuit. Right? What will be the output? Tell me. The output is minimum output because there is no current through RE. The output is 0. This is called minimum output, that is equal to what? 0. Second condition, saturation. Saturation means transistor will act as short circuit. Why short circuit? Because VCE is negligible. VCE is negligible. So what is the highest voltage? Highest voltage is 12 volt. This is the VCC. The highest possible voltage at this point is what? 12 volt. Lowest is what? 0. Now we are having the value 0 and 12 volt. So simply draw the diagram. That is the highest value is the 12 volt. Lowest is the 0 volt. Now the DC point. We are placing the DC point at what? 7.3 volt. 7.3 volt. That is the DC output voltage. Now what is this gap? This gap is 4.7 volt. If undistorted output is required, then this gap should be also 4.7 volt. Why? Undistorted means what? We are getting the sinusoidal signal, like this is the sinusoidal signal. Okay. So ये है swing. So what is the total swing of this? 4.7 plus 4.7, that is what? 9.4 volt. That is the swing. Okay. So ये होगा आपका swing. Now, if we want the maximum swing, if we want the maximum swing, then this point should be in what? Middle of active region. What is the meaning of the middle of the active region? Means if we are placing 6 as a point, right? Like this is the 6. 6 volt as a operating point, then there will be a maximum swing. Undistorted output. So Q point is normally placed in middle of active region to get the maximum undistorted output. I think this question is also clear to you. तो देखिए गेट में ना स्ट्रेट फॉरवर्ड क्वेश्चन नहीं होंगे. They will ask what? Numerical. They will ask this type of numerical, conceptual numerical. So that is on what? Emitter follower, common collector configuration. Okay, swing. Sir, I thought we have to make the AC model. So no, Dheer. In this case, no need to find the, no need to get the AC model. No, because what is the maximum swing is possible, then simply you have to find what? DC at this point. What is the middle DC? What is the maximum? What is the minimum? Okay, and then very simple basic concept, get the minimum difference from this point, maximum point or minimum point. If the 4.7 is the minimum, twice of this will be the swing. If this difference is minimum, twice of this will become the swing. Simple logic. In this case, what is the swing? 12, that is the 6 and 6. So what is the swing? 12 volt. That is the maximum swing when the Q point is in what? Middle. It is in middle. 6 volt is the middle one. I think this question is clear to you. So that is the question on what biasing and stabilization. Now next one. So that is the diagram. Q point in the middle of the active region, right? This is the active region. Change in the current because of there is a change in the output current because of the input current. These are the different values of IB. This is the VCE. This portion is called saturation. This portion is called active region, and that portion is what? Cutoff region. And this is the Q point in the middle of active region in case of common emitter configuration. In case of common emitter configuration. राइट तो अब आपको समझ में आ गया क्यू पॉइंट को मिडिल में क्यों रखते हैं. मिडिल में रखते हैं टू गेट व्हाट? मैक्सिमम स्विंग, faithful reproduction of the input signal, fidelity of the system. Okay. Sohail, if there would be have been a collector register, can then we have to verify. Why not? अगर आपने collector register राइट तो यहां पर देखो ये जो है अगर आपने यहां पर लगा भी दिया एक कलेक्टर रजिस्टर, then you have to calculate the value. Simply write down the KVL and you have to find the value of VCE. This is the register here. No problem. Write down the KVL and find the value of VCE. If this VCE is greater than what? 0.2 volt. It is not in saturation. It is in active region. It is in active region. Okay. अरे 5 वोल्ट भी आ जाए नो प्रॉब्लम है. 5 वोल्ट आ गया तो कोई बात नहीं है. 5 वोल्ट आ गया तो नीचे से कितना हो गया? 5 एंड ऊपर हो गया 5. 5 प्लस 5 इज व्हाट? 10. 10 विल बी द स्विंग. 10 वोल्ट विल बी द स्विंग ढीर. कोई फर्क नहीं पड़ता अगर आपका यहाँ पे Q.5 में आ जाए तो आप हमेशा हर कोई ध्यान रखिए भाई इसको. अगर आपकी वैल्यू यहां आ जाए 5 वोल्ट पे आ जाए और मैक्सिमम वोल्टेज 12 वोल्ट है, ये 5 है ये 0 है, तो ये आपकी स्विंग हो गई. नीचे वाला गैप ले लो 5 ट्वाइस ऑफ दिस, तो व्हाट इज द स्विंग? 10 वोल्ट. स्विंग विल बिकम व्हाट? 10 वोल्ट. ओके, ये है वैल्यू. चलिए अब आगे बाइसिंग से आगे बढ़ते हैं. अब मैं बात करने वाला हूं स्मॉल सिग्नल मॉडल की. देखिए आपके लिए मैं पीडीएफ में अवेलेबल है. जो चीज मैं आपको बता दूं जो आप पढ़ सकते हैं, जो भी मैंने बताया है. दैट इज व्हाट? क्यू पॉइंट स्टेबिलिटी इज अफेक्टेड ड्यू टू टेम्परेचर. इट डबल्स फॉर एवरी 10 डिग्री राइज इन टेम्परेचर. दैट इज व्हाट? माइनस 2.5 मिलीवोल्ट पर डिग्री सेंटीग्रेड. इन सम बुक्स इट इज माइनस 2 मिलीवोल्ट पर डिग्री सेंटीग्रेड. Beta is highly affected due to the replacement of transistor. These are the theoretical question. This year MSQ will play a crucial role in your selection. So, my dear students, please prepare what? Theoretical part also. Theoretical part also. And then second one, stability factor. There are 3 stability factor. One is called S dash, and what? S double dash. Already I have given you the idea about that, right? Now these are the different biasing techniques, stabilization techniques, biasing techniques, and what? Compensation techniques. So what are the biasing techniques and compensation techniques? Collector based bias circuit, cell bias circuit, diode compensation, transistor and thermistor compensation, and what? Transistor compensation. Right. Okay, that Matholi, thanks for that. Okay, last month as I asked you tips, hope you remember. Okay, ये आया ना, that is number of questions in interview from what? Analog, because it is a core subject, and for VLSI we have to get the command over what? EDC and analog, right? To get the command over what? Transistor, get the command over MOSFET, MOS capacitor. These all topics are important. Okay, so which type of questions, Matholi? If you have idea about some one or two questions, then you can write in the comments box. Okay, interview questions. Now this is the diagram for what? Diode compensation. Always remember there may be a question. This is the diode, diode compensation. We are connecting the diode here, that is the RE is already connected here, diode is connected here, RC is connected here, RB is connected here, VT is connected here. This is important diagram, right? There may be a question on this diagram. Always remember, this diode, try to understand, this diode is forward biased by using this battery and RD. So there may be one question, what is the role of battery and what is the role of what resistor in this diagram? So simply this battery and RD is connected here to make the diode forward biased, Now what about this diagram? This diagram is used for what? Silicon transistor, because in case of silicon, VB is highly affected due to temperature, and the change in ICO is not so important in case of what? Silicon. Now this is the VD when the diode is what? Because of this line, the diode is what? Forward biased. So if we are getting this type of diagram, don't worry, simply write what? 1 KVL. Simply write what? 1 KVL from this point to this point. When I am writing the 1 KVL, what is the current here? IC. What is the current here? IC plus IB. What will be the question? This is the diagram for compensation of change in what? VB. Second diagram, it is useful for what? Silicon diode, right? Silicon transistor. Third case, find the value of IC and what? IB. Find the value of IC and IB. So in this question, first of all, assume that the transistor is in active region and diode is what? Forward bias. If the transistor is in active region and diode is forward bias, then you can write 1 KVL here. What will be the KVL? That is the VT is equal to IB RB plus what? VB plus IB. If it is in active region, always remember I can write IB plus IB, 1 plus beta times of IB into RE. IB into RE plus what? This is the minus plus VD, and when I am putting the numerical value, this is the 0.7, this is what? 0.7. 0.7 cancel out. You can cancel the VB and VD and directly you can find the value of IB. What is the value of the IB? VT divided by what? RB plus 1 plus beta times of RE. And from this you can find the value of IC. What is the IC? Beta IB. And then you can write 1 KVL from this point to this point to find the value of what? VC. To find the value of VCE. Very simple question. If the diode is connected and if it is mentioned there that the diode is forward biased because of this battery V positive and RD, then directly you can solve this type of questions. Okay. So what is देखो ये है, देखिए please read that comments in interview, or that is what is the need for the instrumentation amplifier, right? Already I have given instrumentation amplifier is what? Differential amplifier. Okay, so what are the uses for comparison and other things? So this type of questions, a number of questions from what? Analog, number of questions from analog. अभी चलेगी क्लास, अभी तो 1.5 घंटे हुए हैं, अभी तो टाइम है, let them laugh. 10 minutes का ब्रेक भी मिलेगा आप लोगों को, और that is the diode compensation. That will be the question. If this is the question, 2 marks question, find the value of IC, find the value of IB, then simply write down the KVL that the diode is forward biased, this is cancel out, this is 0.7, that is 0.7, and directly you can find the value of IB, then you can find the IC is equal to what? Beta IB. Write down the KVL from this point to this point and you will get the value of what? VCE. If this VCE is greater than 0.2 volt, definitely the transistor is in active region. Right? Okay. Yes, silicon diode, because VB in ICO is it is in the range of what? Nanoampere. So rise in ICO is negligible. Rise in ICO is negligible for this diagram. अब आती है बात, ये देखो डायग्राम, दूसरा जो डायग्राम है अभी वी आर गेटिंग This type of diagram, again here we are connecting the diode, here we are connecting the diode. This diagram is used for what? Silicon transistor. If this is not for silicon, that is for what? Germanium. Germanium. Why? Because it will compensate what? Reverse saturation current. This is the compensation of ICO. This is the diode compensation of ICO, or in case of germanium, ICO it is in the range of what? Microampere, or in case of silicon, ICO it is in the range of what? Nanoampere. This is very, very small. No need to compensate the change in ICO in case of what? Silicon, but it is important in case of what? Germanium. And that's why this diagram is preferable for germanium. That will be the direct question, germanium. Now, very simple. Which type of questions? Find the IC again. Everyone, what is the value of the IC? Tell me. Now, in this case, you have to consider the reverse saturation current. Reverse saturation current means IC is equal to beta IB plus 1 plus beta times of what? ICO. That is the formula. Always remember. Then, this voltage is what? VBE. You can find the I. What is the I here? I is given as VCC minus VBE upon what? R1. VCC minus VBE. This is the VBE upon what? R1. Or this is the again reverse saturation current I0. In question, the value of the I0 will be given. That is the reverse saturation current for the diode. What will be the value of the IB? IB will become I minus I0. IB will become I minus I0. Put this value of IB in this equation and you will get the exact value of IC. It is clear to you, everyone? These are the standard diagram for what? Compensation technique. अरे जरा ये बताओ, अब ऐसे ही सेशन करना है क्या? एक बार आप अपने स्टूडेंट्स वगैरह को, आप ही लोगों ने तो डिमांड की थी मॉसफेट, और उस पर पूरा आप एक बार बता दीजिए. तो देखिए, मॉसफेट एंड बीजेटी वी आर गोइंग टू गेट व्हाट? डिफरेंट टाइप्स ऑफ क्वेश्चंस. सो आई simply I am covering what? All types of topics. They may ask this type of questions on what? Swing, on collector based bias circuit, self bias circuit, or what? Diode compensations. So these are the questions on what? Biasing techniques. Now we are entering into what? AC analysis, that is called gain of the system. So if this is the diode compensation, what will be the theoretical question? This is useful for germanium, that is for ICO. Then numerical means what? Calculate IC. Calculate what? IC. So IC is equal to, what is the IC is equal to? Beta IB plus 1 plus beta ICO. In this question, definitely they will give the value of what? ICO and what? I0. Or it may possible they may give the value ICO and I0 equal. ICO and I0 equal, and this question will become what? MSQ. What will be the MSQ? This diagram is useful for what? Germanium. Second MSQ, this diagram is for compensation for ICO. Third, the value of the IC. If the ICO and I0 is given, then this is the value of the IC. That will become what? MSQ. Numerical plus theory. Numerical plus theory. Okay, Ayan. Probability in mathematics and analog marathon and running in parallel. That is the problem. ये कैसे हुआ? That is in Hindi batch or English? Okay. No problem. चलने दो, अब बाद में देख लेंगे. तो अब आ गया है ट्रांजिस्टर एंड थर्मिस्टर कंपनसेशन. ट्रांजिस्टर एंड थर्मिस्टर कंपनसेशन. तो बताइए जरा, ट्रांजिस्टर और थर्मिस्टर कंपनसेशन में क्या होने वाला है? राइट. अब देखो, दैट इज द ट्रांजिस्टर एंड दैट इज व्हाट? थर्मिस्टर. R1, R2, RC, RE. This is connected here. Thermistor. It is a, what is thermistor? Lightly doped semiconductor material. Remember this. Lightly doped semiconductor material. That's the transistor, diode, both are for germanium. Yes. That is the material. Always remember, when we are using the compensation technique, the material should remain same. If the diode is of germanium, transistor is of germanium, then diode should be of germanium. If the transistor is of what? Silicon, then diode should be of what? Silicon. Right? That is the technique. Okay. Transistor and thermistor compensation means thermistor is a negative temperature coefficient, means resistor decreases with increase in the temperature. It has the positive temperature coefficient. It is highly doped semiconductor material. It is lightly doped semiconductor material. So questions in GATE exam, if I want to replace the RE, then it should be replaced by what? Transistor. RS for transistor and RT for what? Let thermistor. Now second thing, it should be replaced by what? Transistor. It should be replaced by what? Thermistor. It should be replaced by what? Thermistor. So RS, RT or RE, or sometimes we are placing one thermistor here, RT. So that is the replacement, remember this, right? So here it may be, if I want to replace R1, then it will be replaced by what? Transistor. For stability of the circuit, R2 is replaced by the thermistor. RE, it will be replaced by what? The transistor. RS, more negative feedback. Or if I am connecting extra resistor, then it will be what? Thermistor. It will be thermistor. Okay. So that is the values. Now, next one. अब आते हैं जरा hybrid parameters. What is the hybrid parameters or two-port devices? Now, when we are talking about the Q point stability, S dash or what? S beta, right? Or S double dash. And simply we have to find the value of IC, IB, VCE, VCV. These all are called what? DC analysis or large signal analysis. When we have to find what swing, what is the maximum undistorted swing is possible, again it is a DC analysis. And during DC analysis, all the capacitor will act as what? Open circuit. All the capacitor, internal capacitor will act as open circuit. Now, for AC analysis, AC means what? Small signal analysis, right? We are using what? Hybrid parameter model. So that is the hybrid parameter model means what? Transistor, two-port network. You have the idea about the hybrid parameters, right? But now in GATE exam, hybrid parameter is not so important. Simply get the command over what? RE model and what? RE1 RE model and second one is what? Pi model. So just I am going to give you the RE model and what? Pi model. So what is the RE model here? Pi model, exact model is this one. This is for common emitter. This is for common emitter. This is the base. There is an internal base B dash and this is called base spreading resistance RB. Here it is called R pi. Here it is the R mu, right? And here we are having the GM V pi. V pi is nothing but the voltage across this R pi. Here we are having one resistor that is called R0. And that is the model. This is the collector and that is what? Emitter. This is the pi model at a low frequency. Right? We are not considering the internal capacitance. If we are considering the internal capacitance, this model will become pi model at what? High frequency. And pi model is applicable for low as well, mid frequency, low frequency and high frequency. Okay, for all. Then 1 minute. Okay, अब देखते हैं जरा. This is the V pi, this is the GM V pi. GM, this is very, very important. You have to calculate the GM. In every case, you have to calculate the GM. So what is the GM? Mod of IC by VT. In every numerical you have to calculate the GM. IC means DC current. Already we have calculated the IC. VT, volt equivalent of temperature. What is the value? T by 11,600 volt. So normally in numerical it is given as what? 25 millivolt. Right? It is at 25 degrees centigrade, or sometimes it is given as 26 millivolt, volt equivalent of temperature. Second point, GM is given RE. Now second thing, we have to calculate what R pi. R pi is nothing but HFE by GM, or that is nothing but beta by GM. HFE is nothing but beta, so beta by GM. From this you have to find what? R pi. Base spreading resistance RB, it will be given in the question. So what is the RB? 40 to 400 ohm. 40 to 400 ohm. And already I have given you the reason why the emitter resistance and collector resistance are not considered here. Only the base resistance, base spreading ohmic resistance, 40 to 400 ohm. The typical value is 100 ohm. But always remember, if in particular numerical, if RB is not given, you can neglect it. You can take it 0. No need to calculate the 100 ohm or no need to calculate 40 to 400 ohm. Right? Okay, it is also sufficient. But sometimes, that is the GM, sometimes they may ask what is the GM. So just I am giving you the GM VT. Now, this R mu, because the base and collector is what? Reverse bias, this R mu is very high, 4 mega ohm. So this is very high, in the range of mega ohm, then you can neglect it. Neglect this. And R naught is because of what? Early effect. This is given by VA by ICQ. VA by ICQ. ICQ means what? Quotient current, DC current. And VA is the early voltage. If the early voltage is given, ICQ is given, then you can find the R naught. So Raminder, if the diagram is given pi model and simply it is given find the value of the GM and R naught for the diagram, then you can find. Otherwise, to get the gain, input resistance, output resistance, you can use what? RE model. No problem. Is it clear? Both just, so we are neglecting the R mu. When I am neglecting the R mu, that diagram is called what? Approximate model. So what is the approximate model? And normally we are using this model. Simply neglect the R mu. When I am neglecting the R mu, this will become like this. This is the model. We are using this model. These are the values. If not given in the question, first of all find the GM, then R pi, then this one. And if R naught is not given in the question, means early effect is negligible. If RB is not given, take it what? 0. If R naught is not given, take it what? Infinite. Not given. This is called ideal condition. Early effect is negligible. It will act as open circuit. It will act as what? Short circuit. Then you can use what? This model. Okay. We will solve one question on this model. Okay. With one question, everything will be clear. Are you ready? चाहते हैं आप लोग वैसा हो जाए कि एक ही क्वेश्चन से पूरे कॉन्सेप्ट क्लियर हो जाए इसके, राइट? तो दिस इज द approximate model. If RB is not given, take it 0. If R naught is not given, take it 0. GM V pi means the pi is the voltage across that R pi. R pi. Now, second model is what? RE model. RE model or T model. T model. Approximate model. RE model means this is the model. This is the base terminal. This is the small RE. This is the emitter terminal, and that is what? Collector terminal. And this is the alpha I. Right? This is called what? RE model. RE model. Where what is the RE? RE is given by VT by what? IEQ. Where IEQ is what? DC current. DC emitter current. VT is the volt equivalent of temperature. or alpha. Alpha is the large signal current gain for common base. So it is what? Alpha is nothing but beta upon 1 plus beta. Alpha. Right? Or if the beta is very, very large as compared to 1, this is nearly equal to what? 1. Nearly equal to 1. If the beta is given very large, then you can neglect the base current, that IB will become 0. IC and IE will be equal. So these are the precautions. IC and IV will be equal. So that is the diagram. That is the diagram. So two models, only what? Pi model and RE model. Just I am going to give you one question and how we can solve, how we can get the answer for this particular question. I am going to give you the general answer, general solution for that question. So what is the general solution? Watch this. Normally that is the question. This is the RE, this is the output, RC, VCC, potential divider is connected here, potential divider is connected here, R1, R2, the input is given here. This is the CC2 and here the input voltage is connected. Okay, Vs. Right? Now, RC and RE CC2 and that is the value. अब ये question है, right? That is the general question. Second one, हाँ मैं PNP के लिए भी बताऊंगा थे दोनों PNP in AC analysis it doesn't matter whether it is a PNP or NPN, right? Same model we can use. This is the first question, right? Second one, we are getting this type of question. Potential divider biasing, again in every diagram there will be a potential divider biasing. But here we are having one resistor RL. Here we are getting the output with respect to ground. This is the RC, this is the VCC, that is the R1, this is the R2, this is the bypassed resistor RE, this is the RE, and this is the C, CC2. Here it is given as the input. This is the normal question, right? So here it is again bypassed here. Normally it is bypassed. Now, so these are the two general questions. Ready? Ready to solve this type of questions, everyone? With this question, you will get the idea about what AC analysis of RC coupled circuit. This is nothing but RC coupled circuit. Okay then. First of all, always remember CC1, CC2 and C. These are very, very large. CC1, CC2 and C. These are very, very large. Why large? So that these capacitor will act as short circuit during AC analysis. During AC analysis, all these capacitor will act as short circuit. CC1, CC2 and what? C. It will short circuit the resistor. But always remember, very, very large, therefore short circuit during AC analysis. During AC analysis they will act as what? Short circuit. But all these capacitor will act as what? Open circuit during what? DC analysis. So already we have solved number of questions on during the DC analysis. So DC analysis, simply this capacitor will act as open circuit, this will act as open circuit, this will act as open circuit. Use the potential divider, find the VTH, RTH, and then you can find the value of IC, IB or what IE. If the beta is given very, very large, then directly you can find the value of what IE. If there is any problem during DC analysis, already we have solved number of questions. Now, during AC analysis, During AC analysis, what will be the method? During AC analysis, this capacitor will act as short circuit, that capacitor will act as short circuit. Then you can use what? Any model. For example, I am using what? Just I am using RE model. So there are two models you can use. If I am using the RE model, draw the RE model. This is alpha I, and then this is the resistor. This is the collector terminal, this is the emitter terminal, and that is the base terminal. First of all, from the DC analysis, you have to find the IE and then find the value of RE. What is the value of the RE? VT by IEQ. From the DC analysis, find the IE and then find the RE, VT by IEQ. Then we can use this model. Simply, emitter. Try watch this diagram. Emitter is connected to ground because this capacitor will act as short circuit to make a common ground here. This is the common ground. Right? That emitter is connected toward ground. Second, from collector to ground, what is connected here? RC is connected here. Collector to ground, RC is connected. Normal question. For electrical students, this is very, very important. Here we are taking the output. अब बोलेंगे what about this VCC? Always remember, during AC analysis, this all the DC source will act as what? 0. If it is voltage source, it will act as short circuit. If it is current source, it will act as what? Open circuit. Make it open. Now make it short circuit to RC. This point, collector is connected toward ground, and we are taking output from the collector. Now from base to ground, R1 and R2 are connected. So this is the R1 and R2. And here we are connecting the V0, VI or VS, input signal VS. This capacitor will act as short circuit. This is the base terminal. From base to ground, we are connecting what? VS. And that is the case. Very simple, very, very simple diagram. Is it clear? RE model? Right? Yes, you can write. HFE by GM means what? HFE for AC analysis and H capital FE is for what? DC analysis. AC and DC analysis. That is the difference there. But normally we are using the HFE, DC and AC both equal. But practically they are not equal. Okay, because of early effect. But we are not considering it. Then second thing. Simply, if the mid-band voltage gain is required, V0 by Vs. This is called mid-band voltage gain. For mid-band voltage gain, simply you can write the output minus alpha IE into what? RC. Because the current here is minus alpha IE. Now, what is the current here? Always remember this current is IE because it is an emitter terminal, and this current is what? IB. We are neglecting the base current. So what is the output here? Vs. So what is the output here? Vs. It will become IE into what? RE. IE cancel, and what is the answer? Minus RC by RE. And that is the answer. Very simple question. Very, very simple question if we are using the bypassed RC. I think now the use of model is clear to you, everyone. Use of model. So what is the RE model? This is the RE model, minus alpha I, RC. You can find the output, and then from this is the parallel. You can find the value. Okay. Now, if in this diagram, in a similar diagram, RL is connected here. Let RL is connected here. What will be the change? Simply connect the RL between collector and ground. Simply connect the RL here. No problem. Now these two resistors are in parallel. If these two resistors are in parallel, what will be the change in the gain? Only RC parallel with what? RL. You have to write RC parallel with the RL. Finished. If the RL is connected, don't worry, but you have to consider RC dash. What is the RC dash? RC parallel with the RL. So in this, everything will remain same, but you have to use minus alpha IE RC parallel with RL upon what? IE into what? RE. That is the answer for, this is the answer for this diagram, and that is the answer when I am connecting the RL. So that will be the change in the gain. And this is the use of what? RE model. So electrical students, electronic students, it is related to what? Network. Simply connect the circuit with what models, whether it is RE model or what? Pi model, it doesn't matter, right? If suppose I want to solve the similar question by what? Pi model, then similar question by using the pi model, watch this. Remove this diagram. In place of this model, you can use the pi model. What is the pi model? First of all, draw the pi model. Here we are having the RB. Here we are having the R pi. Here we are having the GMV pi. If R0 is given, then okay. If it is not given, simply you can leave it. That is the collector, that is the emitter. And this is the RB basis spreading resistors, this is the R pi, and that is what? V pi. Now, this is the base terminal. From base to ground, because VCC is 0, R1 parallel with R2. Now you can connect R1 parallel with R2. R1 parallel with R2. Here, this is connected at Vs. Since the emitter is bypassed, this emitter is connected to what? Ground. This emitter is connected to ground. Between collector to what? Between collector to ground, this is RC. Because emitter is connected to ground. If we have RC and RL, then you can also connect what? RL here. Now finished. Now what is the Vs? Here the current. Here the current. You can, this is the GMV pi. So what is the V0 here? Try to understand. What is the V0 here? Everyone give me the answer. What is the V0 here? Minus GM V pi R0 parallel with RC. R0 parallel with the RC. What is the V pi here? So V pi is what? Voltage division rule. So what is the V pi here? V pi is nothing but Vs into R pi divided by what? R pi plus RB. If the RB is given in the question, if it is not given in the question, take it 0. So R pi cancel and V pi and Vs will be equal. If R0 is not given, infinite parallel with the RC, it will become RC. That is the logic. Now, put the value of V pi in terms of Vs and get the value of V0 by Vs. So, what is the V0 by Vs for this diagram, everyone? V0 by Vs, this is called mid-band voltage gain. So, what will be the mid-band voltage gain? Minus GM. R0 parallel with RC. चलिए नेक्स्ट पेज में ले लेते हैं. What will be the mid band voltage gain? AVS V0 by Vs. It will become minus GM R0 parallel with the RC into, देख रहे हैं आप, this is the value R pi divided by R pi plus what? RB. तो किसी ने कहा था सर आई एम कंफर्टेबल विद व्हाट? आई एम कंफर्टेबल विद RE model. Then how I can use this? So my dear friends, if R0 is given, RB is given, then we have to use what? Pi model. Is it clear? So pi model, directly connect it and that will be the answer. Any doubt? To put the value of V pi here and then get the what V naught by Vs, that will be the answer for this question. Voltage division rule, that is the reason. So in particular numerical, if the base spreading resistor is given, then you have to find the value of the GM. So that model which is having the R mu, RB, R naught in hybrid model is for mid frequency. No, if R mu is given, RB is given, R naught is given, that is what in mid frequency. Mid or low frequency both are same, right? For high frequency we have to consider what internal resistance, internal capacitance, junction capacitance, diffusion and transition. Okay, diffusion and what transition capacitance. Right. Now I think up to this point everything is clear. So that is the model, that is the use of what pi model connection, right? This is the R pi, RB, and if RL is given, you can directly connect RL parallel to what RC. Then the V naught will become what? Minus GM V pi R naught parallel with RC parallel with what RL. If R naught is not given, then it will become minus GM V pi RC parallel with what RL. RC parallel with RL. R naught is not given, take it infinite. RB is not given, take it 0. Very simple logic. Okay then. अब देखते हैं what is the shortcut. Finally the shortcut is directly you can use this shortcut. If this RE is given, this is the RC. Normally there are 4 types of diagram. Potential divider biasing is given here, but just I am giving you one shortcut. There are 2 types of diagram. This is bypass, this is unbypassed, this is the RC, that is the RC, this is the VCC. And you have to find the mid-band voltage gain, mid-band voltage gain. It is bypassed, it is not bypassed. So approximately the answer is AVS is equal to V naught by Vs. It will become minus RC by what? Small re plus capital RE. यहाँ आपको एक internal resistance है. There is one internal resistance not seen here, but you have to calculate the small re. What is the small re here? Vt by IE. Vt by IE DC current, and then you can use this formula minus RC upon small re plus capital RE. But normally this RE is it is in kilo ohm and that is in ohm. We can neglect small re and that answer will become minus RC by RE. So please tell me, what about the AVS? Overestimated or underestimated? Overestimated or underestimated? That will be the question. So that is the approximate answer for this question, minus RC by RE, or exact what? Minus RC upon small re plus capital RE. But if the RE is bypassed, always remember there is an internal resistor. What will be the answer? AVS is equal to V naught by Vs minus RC by what? Small re. You can't neglect small re because this time RE is bypassed, then you have to consider what? Small re. Directly you can use this formula. Right? Okay. But model will remain same. CC1 and CC2 and CC3 are not the internal part of the transistor. We are connecting the CC1, CC2 and CZ outside the transistor. Right? This value is what? The magnitude is what? Overestimated because we are neglecting the small re. This value is overestimated. If it is bypassed, always use this formula. These are the 2 diagrams. Another two diagrams similar to that. If in this diagram one resistor is connected here, if one resistor is connected here like this RL, and we are taking the output, RL, and we are taking the output, then what is the change? everything will remain same because it is unbiased, denominator will remain same, but in numerator you have to use what? You have to use RC parallel with what? RL. This is the change. Here you have to use RC parallel with what? RL. That will be the answer. But everything will remain same. Bypassed or unbypassed. These are the 4 diagrams. Here we are taking the direct output without RL. Here we are taking the direct output without RL. So this is the common emitter RC coupled amplifier, and normally we are getting the question from midband voltage gain. Simply connect all the components, or directly you can use the shortcut. So electrical students, you can directly use the shortcut, right? So that is the answer for this particular question. तो ये है मेथड. नंबर ऑफ क्वेश्चंस ऑन मिड बैंड फ्रीक्वेंसी. ओके, अब आते हैं जरा व्हाट इज द रोल ऑफ द कपलिंग कैपेसिटर. तो जस्ट आई एम गोइंग टू गिव यू द आइडिया अबाउट द कपलिंग कैपेसिटर एंड सो ऑन. अब देखते हैं भाई थोड़ा सा, और आप स्टूडेंट्स को बुला रहे. 10 मिनट्स का मैं ब्रेक दे रहा हूं आप लोगों को. जस्ट आई एम गोइंग टू गिव यू द 10 मिनट्स ब्रेक, एंड आफ्टर द ब्रेक प्लीज ट्राई टू सॉल्व दिस टाइप ऑफ क्वेश्चंस. 1 minute. Now, what is the answer for this question? Design the circuit to obtain the ID is equal to 80 microampere. Right? तो यहां पर actually design the circuit का मतलब है, right? Find R and what VD. You have to find the R and VD. This is the not fixed. Find R and VD. You have to find the value of R and VD. Let NMOS has the VT is equal to 0.6 volt. Mu and CUX, that is called K and S, is equal to 200 microampere per volt square. L is given as 0.8 micrometer. W is given as 4 micrometer. That is, here the drain is connected to what? Gate. Drain gate biasing. Right? It is here connected. And then, if this is connected, there are 3 regions: triode region, saturation region, and what? Cutoff region. So first of all, give me the answer. What about this transistor, whether it is in a triode region, cutoff region, or what? Saturation region, and then find the value of R and VD. That is based on biasing and stabilization of what? MOSFET. This is the biasing and stabilization of MOSFET. So just 10 minutes break. Try to solve this question. Okay then. There for AC analysis it doesn't matter, but for DC analysis you have to change what? Direction of IE, direction of IC, and direction of IB, and then what? IC is equal to alpha IE. So I will just after the break I will give the idea about that. Okay. हेलो, हेलो एवरीवन, वेलकम बैक. नाउ व्हाट इज द आंसर फॉर दिस पर्टिकुलर क्वेश्चन? क्या है भाई आप लोगों का आंसर जरा बताना. यस प्लीज. ओके. 25 kilo and 1 volt, one student is giving a 22.4 25 kilo 1 volt. Okay, so this is a question on what biasing. This is a question on biasing. Designing means what? You have to find the unknown resistor. The biasing is given and designing is given, and you have to find what? Unknown resistor. Always remember, if this drain is connected to a gate, drain is connected to gate, it will be in saturation. No need to check saturation, right? And during if it is in saturation, why is breaking? Right, it is not clear. 1 minute. Hello, it is not audible. Everything is fine. That is, if the drain and gate is connected, it is in saturation. Second thing, जैसे होता ना, in BJT, if the collector and base is connected, it is in active region. Similarly, it is in saturation region. Since for saturation, what is the condition? VDS should be greater than what? VGS minus VT. VT is the threshold voltage. GS, VDS and VGS. So what is the VDS? In this diagram, VD and VG are equal because they are connected, and therefore VDS is equal to what? To VGS. So definitely, if these two are equal, then VDS is greater than what? VDS minus VT. That is the formula. Second thing, now this now it is okay. Voice Sachin Dev Misra, everything is fine now. मुझे थोड़ा चेक करना होगा, आप देख लेते हैं जरा. 1 मिनट. क्या है? हाँ, नॉट इज क्लियर. प्रॉब्लम है यहाँ पर, अब देखो. 1 मिनट. Now please inform me that now the sound quality is okay. Yes, yes. ये तो इलेक्ट्रोमैग्नेटिक इंटरफेरेंस आ रहा है, लग रहा है यहाँ पर. चलिए. If VDS is greater than what? VGS minus VT, greater than or equal to, then VD equal to, from the diagram, the VD is equal to VG, therefore VDS is equal to what? VGS, and now the VDS is greater than VGS minus VT. Okay, that is the logic. It is in saturation. Always remember, in saturation, the formula is IDS is equal to half of Kn dash W by L VGS minus VT the whole square 1 plus lambda VDS. That is the actual formula. Okay, again problem. 1 minute. तो चलिए अब थोड़ा अभी भी है. रविंदर कौर नॉट ओके, अभी भी प्रॉब्लम है. चलो देखता हूँ मैं जरा क्या प्रॉब्लम है, थोड़ा सॉर्ट आउट कर ले इसे. Hello. Now please check it is okay. That is half of k, but when we are considering the early effect, then that is the term. Lambda is equal to what? 1 by VA. VA is the early voltage. If we are neglecting the early voltage, okay, now it is fine. If we are neglecting the early voltage, then simply remove this term. Lambda is not given, then simply you can remove. W by L is called aspect ratio. K and S is what? Nothing but mu and COX. Vt is given as 0.6 volt. ID is given 80 microampere. Then you can use this formula. Second formula, we have to find what? VGS. VGS is nothing but equal to what? VDS. Once you will get the VDS, means what? VD, you can find the VD, and 3 minus VD divided by ID will give you the value of R. That is the question. क्या है यहाँ पर? करना क्या है आपको? आपको बस फॉर्मूला यूज करना था. IDS is equal to half of K and S W by L VGS minus VT the whole square. ये दिया हुआ है 80 माइक्रो. व्हाट इज दिस? 80 माइक्रो एम्पियर. 1 by 2. व्हाट इज द K and S? 200 माइक्रो एम्पियर. द यूनिट विल रिमेन सेम. 200 into what is the aspect ratio? W by L. 4 divided by 0.8. 4 divided by 0.8. VGS minus 0.6 the whole square. From this you can get the value of VGS. Okay. So that is 0, 0 cancel out. This will become 16 into 0.8, right? And that is what 2, or this is the 10 divided by 40, right? And this is root over this. 1 minute, otherwise calculation mistake हो जाएगी भाई. यहाँ पर ध्यान दीजिएगा. This is the 2, that will become what? 2, it is multiplied, it is the 16 into 0.8 divided by 40. इसको 2 से अगर मैंने देखो, एक मिनट यार, कैलकुलेशन सिली मिस्टेक करने का कोई मतलब नहीं. आप कैलकुलेट कर सकते हैं. यू कैन गेट द वैल्यू. This is what? 80 microampere is given. 1 by 2, that is what? 200 it is given, into what? 4 and 0.8 is given. 40 divided by 0.8, you can put the 5, or this is, that will become 100. तो अब कैलकुलेशन में सिली मिस्टेक अवॉइड करना है. तो this will become 100 and this will become 40 divided by 8, that is the 5. VGS minus 0.6 the whole square. From this you can find the value of what? VGS. Once you will get the value of the VGS, it is what? Very simple. VGS is nothing but VDS. And what is the VDS? VD minus VS. VS is connected to ground. VS is connected to ground, and that's why this is nearly equal to what? VD. Once you will get the VD, what is the R? R is nothing but VDD minus VD by ID. VDD minus VD divided by what? ID. You will get the value of R. That will be the method. तो चेक कर लीजिए, वेरीफाई कर लीजिए. तो रविंदर कौर, what is the answer for this? And it should be, we are getting the two options. We are getting the two options for VGS. One answer will be greater than threshold and one answer will be less than threshold. Always remember that value should be greater than what? Threshold voltage. Threshold voltage. It should be greater than what? Threshold voltage. Now, this type of questions. But no need to verify always. This is, if this is connected to VG, then it is what? It is in saturation, right? अगर IC is equal to beta, अच्छा आप बोल रहे हैं sir, if we are considering, we are not having the standard formula for that, right? But R naught in model we are using the R naught, or in characteristics there is a we are having one register that is called what? R CE or R naught, that is because of what? Early effect. If we have the idea about the VC, if it is multiplied with what? Divided by that R naught, then we can find the current because of early effect, right? तो आप कैलकुलेट कर सकते हैं. अच्छा, one answer is what? 0.2 volt and one answer is what? 1 volt. तो 1 volt is greater than what threshold voltage, then you have to choose what? 1 volt in this question. ठीक है. अब आती है बात now confusion. Confusion क्या है? That is the NPN transistor and what? PNP transistor and MOSFET and DMOSFET. So first of all, NPN transistor. So normally we are having the question on what? NPN transistor. That is the NPN transistor. What is the direction of the current? This is the IE. This is the IB. That is the IC. Right. Here we are using IC is equal to what? Alpha IE. That is the formula, or normally we are neglecting the ICU. Normally we are neglecting the ICU. In case of PNP, right? Here that is the arrow. This is the RC and this is negative value. Negative value. So what is the emitter current? That is the direction of the emitter current. That is the direction of the base current, and that is the direction of IC, collector current. If that is given, then again you can use the same formula. IC is equal to what? Alpha I. ICO is negligible. And second equation is IE is equal to what? IC plus IB. IC plus what? IB. In this case again we can use the same equation. But in case of NPN PNP transistor, you have to use what? Plus minus VEB. Plus minus VEB. Then this junction is what? Forward bias. This is the emitter and that is the base. And VEB, the value of VBE is what? 0.7 volt. Okay. Okay. That is clear. अच्छा, आपने देखा तो लैम्डा की वैल्यू क्या? वही मैंने बोला ना, VC you have to find what? R naught. R naught is what? VC, sorry, VA by what? ICQ. Then you can use that formula. Okay. This diagram is clear to you, everyone? RC, IB and VCC minus VCC, RC and IB. So this is the PNP transistor. Everything will remain same, but the direction of the current will change. IE will change, IB will change, IC will change, and this is here we have to use what? Minus VCC. Similarly, in case of NMOS, that is the NMOS, right? Simply we are using VGS is equal to VGS less than VT, cutoff. VGS greater than or equal to VT, VDS less than VGS minus VT, triode. What is the meaning of the triode? You have to use the formula IDS is equal to K and S W by L VGS minus VT into what? VDS minus half of VDS square. And third case, if VGS greater than VT, VDS greater than or equal to VGS minus VT, that is called saturation. Saturation. So IDS is equal to half of K and S W by L VGS minus VT the whole square. Okay. Now, in case of P MOSFET, what will be the change? In case of P MOSFET, simply change this value. IDS is equal to K and S W by L VGS minus VT VDS minus half of VDS square. So in case of P MOSFET, VGS, that VT, Always remember the threshold voltage is what? Negative in case of what? P MOSFET. I am talking about the enhancement type. P MOSFET, it will be what? Negative. Then simply we can change the subscript and this will become VSG. If it is less than or equal to mod of VTP cutoff. So that is the change. Second, VSG greater than VTP, mod of VTP. When I am putting the mod, it will become positive. And VSD less than what? VSG minus mod of VTP, then it is triode. So simply change the subscript. In place of GS you have to use SG, in place of DS you have to use SD, SG, and here you have to use the mod. And the formula will remain same. Formula will remain same, but you have to use what? In place of K and S, you have to use what? KP dash. What is the formula for IDS? IDS will become, from the current is from source to drain. The formula KP dash W by L VSG minus mod of VTP into what? VSD minus half of VSD square, half of VSD square. That will be the formula. We are simply changing the subscript. We are simply changing the subscript. Okay. Similarly, in saturation, this will become VSD greater than or equal to VSG minus of mod of VTP. Finished. Same formula, change the subscript. In place of K and S, you have to use what? KP dash. So in a saturation, the formula will become half of KP dash W by L VSG minus of VTP mod of VTP, the whole square. Any doubt? So that now normally we are using what? IDS, and remember that IDS is what? The current is from what? Source to drain. Current will be from the source to drain. We are using the same notation, but the current is from source to drain. That is the source, that is the drain, that is the gate. This is the voltage, this is called VSG, and that is the current. We are normally it is represented by what? IDS, but actually it is moving from source to what? Drain. Okay, no problem. So, or remember this one: saturation, triode, and what? Cutoff formula. Saturation, triode, and what? Cutoff. So this is for NMOS and that is for what? PMOS. This is the diagram for what? PMOS. These two diagrams are important to understand the questions on what? CMOS, complementary MOSFET. For electrical student, the CMOS is not so important. For electronics student, CMOS. We are getting question from what? CMOS. 2 marks question from CMOS. Now, what is the small signal model for the MOSFET? Small signal model for the MOSFET. Here it will act as what? Open circuit. This is the source. This is the source. This is what? Gate. This voltage is called VGS. We are using the small, and here this is called GMVGS, and this is the RD, drain resistance. Right here the GM, again this is called transconductance, and VGS the gate to source voltage, and RD is the drain resistance. That is given by, again that is what? Because of early effect, or sometimes it is written as what? R0, again because of early effect. In some questions it is directly given. If it is not given, then you can take it what? Infinite. and this will act as open circuit because the input resistance is what? Infinity. Input resistance is infinite for that, and that's why it acts as what? Infinity. Okay. Sir, for MOSFET always VT positive, or if MOSFET V1 is given, what sign? Means for NMOS always VT is positive if D MOSFET is given. If D MOSFET is given, then okay, that is the doubt. Just I'm going to give the answer for this question. That is the small signal model, GM, VGS and RD. Right? GM is the transconductance, RD is the drain resistance. Here GM, transconductance, is nothing but change in ID with respect to what? Change in VGS in saturation region. To simply get the formula and differentiate it, you will get the formula K and S W by L VGS minus VT. That is called GM, transconductance. Right? K and S W by L VGS minus VT. Or for P MOSFET it will become Kp dash W by L VSG minus mod of VTP. अब देखो, जो आपके कोई भी दिमाग में अगर क्वेश्चन है पूछ लीजिए. फिर स्मॉल सिग्नल मॉडल, आई एम गोइंग टू गिव द सम क्वेश्चंस ऑन स्मॉल सिग्नल मॉडल फॉर व्हाट? MOSFET. This is very easy. Then we have only one model, that is the model, right? Then question, what is the question here? Try to understand. NMOS. When I am talking about the NMOS, for NMOS the value of the threshold voltage should be what? Positive. Threshold voltage is positive. That is the value. This is the diagram. This is VGS. This is what? IDS. And that is called threshold voltage VT. So it is positive. If, for example, if the mod of VT is given as 1 volt, so VTN will become what? 1 volt only for what? E MOSFET. Enhancement NMOS. E MOS N channel. Is it clear? Now, if it is PMOS, then that is the diagram. What is this VT? Negative VTP. Negative value. It has negative value, minus 1 volt. Minus 1 volt. That is the negative value, VTP. Okay. Yes, you have to understand that the source, from source to drain, it will flow. If ID is given, then always give the direction from what? Source to drain only, or otherwise you can convert the PMOS into what? NMOS. So I think that Siva Kumar, these two diagrams are clear to you. But one student asked one doubt that in D MOSFET what will happen? So D MOSFET, always remember, in case of D MOS, depletion type MOSFET, there is a channel. There is a channel, induced channel. There is induced channel inside the semiconductor. That is the induced channel. Already electrons are present here. In enhancement MOSFET, this channel is not present, and that's why we have to apply the voltage. Right. This is the VGS. This is the SiO2 layer. That is the drain terminal. This is the source terminal. And that is the body terminal. Now, if that VGS is 0, if this VGS is 0, again there will be a current. Again there will be current. Okay. This is the D MOSFET. But when we are giving the positive voltage, P type, when we are giving the positive voltage, it will attract the electron and the conductivity of channel will increase. Or when I am giving the negative voltage, it will repel the electron and ultimately the conductivity will become 0. So what about the curve for N MOSFET? One student asked one question on this. So what will be the equation for the current and so on? So that is the equation. This is the diagram. This is the IDS and this is the VGS. For N channel, this is called threshold. In case of what? D MOSFET, this is called VGS cutoff or threshold voltage. VT. Now this time what is the VT? VT is negative. VT is what? Negative for D MOSFET. Because for this value, it will repel the electron and the conductivity of channel will become 0. And when VGS is 0, there is a conductivity and this current is called IDSS. Drain to source saturated current when VGS is equal to what? 0. So everything will remain same, but only the VT will change. Or here we can apply the VGS positive or negative. Both VDS is always positive. VDS is positive. And the formula by only the VT is negative. Only the VT is negative. Everything will remain same. And VGS we can use what? Positive or negative value. Any doubt? That same formula for N channel MOSFET. That is E MOSFET. But what is the value of the VT here? Negative. You have to use the negative value without what? Mod. Without mod you have to use what? A negative value. Here use कीजिए and you will get the answer. Okay? That is clear to you? कुछ भी हो देखो, concept हमेशा if suppose in D MOSFET, suppose we are getting the question from the D MOSFET, let the VGS cutoff is I am getting the -5 volt. For -5 volt, there will be the no electron in the channel region and it is what? It is in cutoff, right? And now I am applying what? -4 volt. Okay, -4 volt. Then what is the effective voltage? Tell me. What is the effective voltage? The -5 volt is the threshold voltage and I am applying the VGS is equal to -4 volt. What will be the effective voltage? Everyone please tell me. In case of D MOSFET, this is very important concept. So I am writing the question that VGS is less than what? VT. This time negative, cutoff. We are using the negative value here. VGS greater than VT and VDS less than VGS minus VT. Triode. This is the for the triode. What will be the formula? IDS is equal to K and dash W by L VGS minus VT into what? VDS minus half of VDS square. Formula will remain same. Yes. If I am giving it -4 volt, VT is what? -5 volt. -4 minus of -5 volt, it will become what? 1 volt. What is the effective voltage? It will become 1 volt. And that's why no need to put the mod here. No need to put the mod here. The formula will exactly remain same for N MOS, E MOS, N channel D MOS. N channel E MOS, N channel D MOS, the formula will remain same. But remember, always remember, it may be negative or positive. Negative or positive. VT is negative here. So negative will become positive. And the VDS is always positive. This is positive. Because the current will flow from drain to source. Drain to source. Use the same formula. Okay? Is it clear? Same. But only we can say there is a shifting of the curve of N MOS, E MOS, left side. Simply we can shift and the value will become negative. Everything will remain same. Right? If the VGS is less than VGS cutoff, conductivity of the channel is 0. When we are increasing the VGS greater than VGS cutoff, the conductivity of channel will start increasing. Okay, that is the case. But when we are taking the VGS 0, this side is called what? D MOSFET. Here it acts as what? E MOSFET. Enhancement type, depletion type. Formula will remain same. Okay. तो एक स्टूडेंट ने ये क्वेश्चन पूछा भी था. तो सर सैचुरेशन में भी वही हाल है. सेम सैचुरेशन फॉर सैचुरेशन इन डी मॉसफेट always check this value, VGS greater than VT, threshold voltage, it is negative, no doubt it should be greater than VT. And second one, VDS should be greater than equal to VGS minus what VT, that is the general formula. What is the formula for IDS? Half of K and S W by L VGS minus VT the whole square. Right? Now, one important thing, yes, VGS cutoff means threshold voltage. VGS cutoff means what? Threshold voltage. Yes, in case of D MOSFET. Now, what is the current when the VGS is equal to 0? IDS is equal to what? IDSS. IDSS. So if it is given, IDSS is given, put here IDSS. In some numericals, half of K and S W by L is not given. Put the VGS is equal to 0 minus of VT the whole square. Then what is the value of the K and S W by L? K and S W by L aspect ratio will become 2 times of IDSS upon what? VT square. अब देखिए, because it is a square, it doesn't matter whether it is negative or positive, and that's why I am writing the VT square. What is, because it is a square, it doesn't matter whether it is positive or what? Negative. So 2 IDSS upon VT square. So threshold voltage, if it is negative given, you can use the negative value. If it is positive given, you can use the, but in case of N channel D MOSFET, threshold voltage will be negative. I think now this is clear to you. K and S W by L, 2 IDSS. What is the IDSS? Drain to source saturated current when the VGS is equal to 0. From this you can find the value of K and S W by L. So sometimes IDSS is given, threshold voltage is given, but K and S W by L is not given in the question. JFET is not in our syllabus. JFET is not in our syllabus, right? And that's why simply focus on what? D MOSFET and E MOSFET. Okay, any doubt? Any doubt in this question? So if what is the IDSS? No, IDSS is not the current at the edge of the saturation. IDSS is the current when VGS is equal to what? 0. Already it is in saturation. Already, because we have the channel, and VDS is greater than, if suppose I am putting the, for example, VGS is equal to 0, so what is the VDS? VDS should be greater than or equal to VGS minus VT. For example, let the VT is equal to what? -3 volt. If I am putting the VGS is equal to 0, so what is the condition? VDS should be greater than or equal to 0 minus of -3, that is equal to what? 3 volt. If it is greater than 3 volt, it will be in saturation. Okay, here it is clear. It is in what? Saturation. Once it is in saturation, so what is the saturated current? IDSS is the saturation, drain to source saturated current when we are giving the VGS is equal to 0 value. Then you can use this formula. Use this formula and get the value of what? K and S W by L. So in a particular numerical, that is called characteristics of D MOSFET, IDSS. Right? So ये graph है that they may give you the graph IDSS. So from this diagram we are getting the IDSS, we are getting the VGS cutoff, and by taking the slope of this we can find the GM. What is the GM? Change in ID because of change in VGS. That will be the question. From this graph we are getting IDSS, we are getting the GM, we are getting the VGS cutoff. Okay. I think now there is no doubt. So that is about what? D MOSFET. Okay. Don't put mod here. Okay. And now I am just giving you the simple trick. Here, if you are not comfortable with the P MOSFET or PNP transistor, then simply convert it into what? N MOSFET. But change the polarity of the battery also. change the polarity of the battery also. If it is given positive, then make it negative. If it is given negative, then make it what? Positive. Right. Okay. Raminder Kaur, you are giving the ID is equal to IDSS VGS minus VT 1 minus VGS minus VT the whole square. Yes. वो तो standard formula है. If this is the K and dash W by L is replaced by this in this formula, then it will become what? IDS will become, replace this. So 2 cancel, it will become IDSS upon VT the whole square, or simply VT square VGS minus VT the whole square. Put it inside, it will become IDSS. So normally VT we are taking the 1 minus what? VGS by VT the whole square. Why I am taking the VGS and VT? Right, because the magnitude of VGS is normally less than what? VT. Magnitude of the VGS is less than, but it doesn't matter because it is a square. It doesn't matter, we are using VGS minus VT minus 1 or 1 minus VGS by VT. Well known formula for JFET. What is the formula for the JFET? IDS is equal to IDSS 1 minus VGS by what? VP. This is called pinch of voltage. VP is called pinch of voltage in case of what? JFET. But in DMOSFET it is called what? VGS cutoff. Okay, I think now it is clear to you. अब आ गया, तो ये हो गया. अब लास्ट पॉइंट देखिए, दैट इज द क्वेश्चन, दिस टाइप ऑफ क्वेश्चंस, दैट इज असाइनमेंट फॉर यू. ID is given, VD with respect to ground 0.5 is given. Design the circuit means always find the value of the RD and RS. This is the RD and RS. You can take a screenshot, right? And that W is given, L is given. Neglect the channel length modulation. Mu and UX is given. Simply you have to find the value of RD and RS. So this type of questions on biasing of what? MOSFET. Now, what is the small signal analysis of the MOSFET? Small signal analysis, we are having the 3 types of questions. First, find the gain of the MOSFET, right? For example, very simple, very simple question. Find AVS, mid-band gain, that is called V0 by Vs. Maybe question. Now, diagram is given as this is bypass, RSCS, this is called source terminal, RDD is given here, RG, we are connecting the RG, battery is connected, this is called VGG, right? This is the value, and that is the question, right? That may be the question here. Okay. Yes, if extra resistor is connected, then you have to change the polarity. If it is given the negative, then you have to convert it into what? Positive, so that emitter junction should be what? Forward bias. See why it is clear? Emitter junction should be forward bias. If it is in NPN, I am providing emitter is connected to what? Negative value, so that emitter junction should be forward bias. Or in case of PNP, it should be positive value, so that emitter junction should be forward bias. Okay, that is the case. DID by DVDS, what we call this? The change in ID because of change in VDS. There are 2 reasons. If it is in linear ohmic region, that is called what? Resistance, RDS. But if it is in what? Saturation region, the change in ID because of change in VDS is nothing but early effect or channel length modulation. Okay, Dhir, that is the early effect or channel length modulation. It will give you the value of what? R0 or RD. R0 or RD, that is in saturation region. If it is in triode region or it is in linear ohmic region, it will become what? VVR, voltage variable resistor. Voltage variable resistor. तो देखिए RG, RS और CS. अब देखो ये जो क्वेश्चन है, if that is the question, find the gain. Suppose it is given, V0 is given, right? First of all, you have to find the value of GM. What is the value of the GM? GM is given by K and S W by L VGS minus VT. This is the value. In numerical, the K and S is given, W by L is given, or so that complete quantity is given. You have to find the VGS, threshold voltage, it will be given. Always remember this point is called VGS. VGS. Then IDS. IDS in DC analysis. In DC analysis, all the capacitor will act as. Everyone, please tell me. All the capacitor will act as. Yes. You have to change the polarity according that emitter junction. If it is in active region, then emitter junction should be forward bias. So always remember this capacitor. First of all, that is the diagram. Always remember AC analysis and then what DC analysis. I'm going to give you the hint for this question. So DC analysis. During DC analysis, make it open circuit, right? And then this is the RS. This is the VGG. This current is always 0. No role of this RG, but it is in the range of mega ohm. And this is the RD. This is the VDD. There will be the current ID. Same current will flow like this. Now write down one KVL here. When I am writing the one KVL, it will become VGG is equal to what? VGS plus what? ID into RS. ID into RS. So what is the VGS here? VGG. This is the DC voltage connected to what? Gate terminal. It may be 5 volt, 6 volt. Minus what? ID into RS. This is important equation. Second, how we can find the value of, because there are two unknowns. There are two unknowns, VGG and ID. There are two unknowns, ID and VGS. So second equation, normally when we want to find the gain, that will be in what? Saturation region. You can use this formula. IDS is equal to half of K and S W by L VGS minus VT the whole square. Now we have the two equations and two unknown. So this is the first equation, that is the second equation. Put the value of what? ID in terms of, put the value of VGS in terms of what? ID. This VGG will be given in the question. Find the value of ID. From that you have to find the value of VGS. From VGS you have to find the value of what? GM. This is called DC analysis. This is called what? DC analysis. I think now this concept is clear. After DC analysis, now a very simple question, very simple one. Now you can use what? AC analysis model. Very simple model. Here use the GM VGS. Use what? If RD is given, then you can use RD here. That is the drain terminal. This is the source terminal. This is the gate terminal and that is the source terminal. तो ये देखिए, ये तो मैंने आपको बता दिया. That is the how we can find the DC analysis. During DC analysis, use this formula. Write down the one KVL. Write down the equation for the saturation. We are having the two equations, two unknown. Find the value of VGS and ID. Right, and so on. If early voltage is given, then you have to find what? RD. During DC analysis, if the early voltage is given, then you have to find the RD, IDQ. So IDQ is nothing but IDS. During DC analysis, use this formula and also you have to also find the value of the RD. To find the value of the RD, find the value of the GM, then you can use this model. Then you can use this model, this one. Now, once you will get the value of the GM and RD, now always remember during AC analysis, this will act as what? 0. This capacitor will act as short circuit. This capacitor will, here we are using the input. This capacitor will also act as short circuit. This is the input connected here. Now this battery will act as short circuit. This capacitor will act as short circuit, therefore source is connected to ground. So connect the source to the ground. Here one resistor is connected, that is called RG. Don't worry about this resistor. This is the RG because it will act as short circuit. Now this capacitor will act as short circuit. Here Vs is connected with respect to ground. This is the voltage. That is the ground. Source is the connected to ground. Now because this will act as short circuit, RD is connected here. Capital RD. Okay, very simple diagram. Very simple diagram. Now here we are taking the output for electrical and electronics student. Now you are going to get the question from what this diagram, and always remember this is the G and this is the S. What is the voltage here? VGS. VGS is nothing but Vs. So what is the gain? V0 by Vs. V0 by Vs, that is nothing but what is the V0? V0 is equal to minus Gm VGS RD parallel with capital RD upon what is the Vs? Vs is nothing but VGS, parallel connection. VGS is cancelled, and what is the answer? Minus Gm RD parallel with what? Capital RD. Finished. 180 degree phase shift. That is the use of this model. I think now it is clear to you, everyone. Give me the comments. So after DC analysis, directly MOSFET, this will act as what? Short circuit, RG, this is the CC2, RD and so on. CC1 VDD is equal to 0. Okay. So that is the use of what? Model. Okay. Now there was one question on this model. तो ये तो बहुत ही simple सा है. Find the mid band gain and then what is the input resistance seen by the Vs. If it is asked what is the input resistance seen by the Vs, not infinity. Input resistance seen by the Vs is what? RG, because the input resistance up to this point is infinite. Always remember, up to this point it is infinite, but infinite parallel with RG is what? RG. They may ask this type of questions. Okay, what is the output resistance? So output resistance is sometimes called Thevenin's resistance. So this is the output resistance. It is a load. It is always, remember, it is a load. So to calculate the R0, we have to make what? Vs is equal to 0. When I am making the Vs is equal to 0, VGS will become 0. This current source will act as open circuit and the output resistance will become what? RD, small rd. Small rd. It is clear? Right? Gm is not equal to what? ID by, क्या लिखे आप? What is the Shiva Kumar? What is the answer? ID by Vt. No. That is not the trans conductance. It is what? You are writing that IC by Vt in case of what? Transistor. In case of transistor. Here you have to find the Gn, trans conductance. Next. And last question, then I will arrange what extra part for that, because parallelly we are having the session on what? Maths, right? So one last question, then I will ask them to arrange what extra session, that is the part 2, where I will cover the high frequency analysis of MOSFET and what? BJT. Please join my Telegram channel. I am sending the link with you. This was the question. Here normally this is the value, this is the RD, this is the VDD, right? Now at this point you have to find what? From this terminal to this terminal you have to find Norton's equivalent. Find Norton's equivalent resistor. Norton's equivalent resistor. That was the question in GATE exam. Right here the input is connected, RD is connected here, VDD is connected here, and you have to find the Norton's equivalent resistor at this point. So normally we are connecting the load here, okay? Normally we are connecting the यार अयान मलिक, आज का सेशन में तो मैथ्स भी पैरेलल हो गया। अब हमको एक पूरा एक सेशन और लेना पड़ेगा करंट मिरर और उसको कवर करने के लिए, हाई फ्रीक्वेंसी और करंट मिरर। जस्ट आफ्टर दिस सेशन आई विल आस्क देम टू अरेंज विद इन 1 or 2 days, okay, within 1 or 2 days. So this is the question, find the Norton's equivalent. Just I will give the idea about the current mirror circuit, don't worry, within 10 minutes I will give the idea about the current mirror circuit. So once it is Norton's equivalent is resistor is required here, means what is the meaning of this? First of all, watch this diagram. Actually here we are connecting one resistor that is normally called RS, or this is the RL, load resistor. Here we are taking the output. This is the RD, this is the VDD, and here we are connecting VI. Now this is the RL, we are getting the output from the source. This is the drain and that is the gate. This is a common drain configuration. What is this common drain configuration? It is called source follower. It is similar to what emitter follower, right? अब देखते जरा, हाँ next. Okay, differential amplifier using the MOS and what current mirror circuit is required. Okay, I have 5 to 6 questions. Okay then. Now that is what RS is equal to RL. RS is equal to what RL. So when we want the Norton's equivalent, always remember, when you want the Norton's equivalent, you have to remove the RL. But in a gate exam already RL is removed, and you have to find the Norton's equivalent across what this terminal. So actually we are removing the RL and we have to find the Norton's equivalent. This RD is given, this is VDD is given, and if this is the question, then always draw the small signal model, and it is AC analysis. It is what? AC analysis. So what will be the answer? If you want the Norton's equivalent, then watch this diagram. First of all, make this VDD is equal to 0. This RD is given here. Make this VI is equal to 0, because to calculate the Norton's equivalent, this will be the 0. That is the terminal A and B. This is the source terminal. This is the drain terminal. Draw the small signal model. What is the small signal model? Draw this small signal model. This is the GMVGS. This is the RD. That is the drain terminal. That is the source terminal. This is the gate terminal. Always remember, if input is 0, it doesn't matter that VGS is 0, because this time the VGS is not 0. Input means from this point to this point. From this point to this point, voltage is called what? Input voltage. And that's why VGS is not 0. Always remember, VGS is not 0 if the VI is 0 in this case. Now, what is the source to drain? There is a terminal. This is the A, this is the B, and this point is connected toward ground. This point is connected to ground, and this is the input is 0, means this is short circuited, right? And what about this voltage? This voltage is what? VGS. From this point to this point, VGS. VI is equal to 0. To calculate the Norton's equivalent, VI should be equal to 0. And here RD is connected. This RD between drain and VDD, RD is connected. Then simply, what is the, no. How we can calculate the RD? Now, if you want to calculate the Norton's equivalent across this point, always remember there is a dependent source, then we have to apply what? 1 volt battery, yes. What is the method from the Norton's equivalent? Network. Connect a 1 volt battery, extra battery, and let this is the current I. Then Norton's equivalent resistor will become 1 by I. You have to calculate the 1 by I. Now this I, what is the current here? GMVGS. What is the current here? I. So what is the current here? I plus GM VGS. I plus GM VGS. Now again the GM VGS here. So what is the current here? Again I. So same current will flow like this I. Now write down one equation here, KVL at the input. You will get VGS is equal to VGS plus 1 volt is equal to what? 0, because Vi is 0. Write down the KVL here. VGS plus 1 volt will equal to 0. So what is the VGS is equal to? Minus 1 volt. Minus 1 volt. This is the equation number 1. Write down the KVL at this loop. This is called KCL, current distribution. So what is the KVL? Start from this. It will give minus 1 volt. This is the minus 1 volt. Plus I plus GM VGS. I plus GM VGS into what? RD. Plus I into what? RD is equal to 0. Is equal to 0. Now we have to find what I. So what is this? This is the minus 1 plus I. What is the common? RD plus RD plus what? This is put the value of VGS minus 1, so it will become minus GM. VGS is equal to 1, RD is equal to what? 0. Tell me what is the I RD plus RD is equal to 1 plus GM RD. What is the 1 by I? What is the 1 by I? Because 1 by I is the RTS. So what is the 1 by I from this? 1 by I will become RD plus small rd upon what? 1 plus GM VGS. GM RD. Are you getting me? So RD plus small rd. So what is the Thevenin's resistance here? That is become RD plus small rd divided by 1 plus GM into RD. That is called Thevenin's resistance or Norton resistance are equal. Yeah. Norton's resistance or Thevenin's resistance. I think now this concept is clear. Simply 1 volt battery connected here and then you can find the value. RD plus RD 1 plus GM RD. Okay, yes or no? This concept is clear to you? So this is all about what? MOSFET. Now, so if the Norton's equivalent at this point it is required, means this is the load resistance. First of all, remove the load resistance and then you can find the value, and that will give you the value of what? Complete formula. Some students, sir, it is 1 by GM. My dear friend, if it is 1 by GM means what? In which case it is 1 by GM? Abid, you are giving that answer is what? 1 by GM. So 1 by GM means what? When the RD is not given in the question. If in particular question, if capital RD is not given, it is short circuited. That is called special case. It is the special case here. This is the short circuit. This is the short circuit and that is required here. Here I am connecting the RS and this is the case. If the RD is not given, so what is the formula for the RN? RN is equal to RD plus small rd upon what? 1 plus GM RD. Right? That is the formula. Always remember this GM RD is called mu in case of what? JFET. Amplification factor, and normally this GM RD is very greater than 1. So GM RD is very greater than 1 and RD is not given, that is equal to 0. So what is the answer here? 1 by GM. I think now this is clear to you everyone. RD is not infinite my dear. 0 not given means what? If you are taking the infinite, this branch will act as open circuit. This is short circuit. RD is equal to 0. Not given means what? You can't remove. Okay. If you are making it open circuit, the complete voltage will come across this. Then what will happen? Circuit will goes into what? It will not work. Okay, RD 0, not infinite. To put the value RD 0, GM RD is very greater than 1. RD cancel, and then it will become what? 1 by GM. So always remember, in electrical branch there was a one question: what is the resistance seen here? What is the resistance seen here? Always remember, first of all find the resistance, Norton's resistance, or that is called what? RN or RTH. So what is the resistance seen here? Here it is nothing but RN parallel with what? RL. RN parallel with what? RL. That may be the question. So always remember, watch the arrow. If that is the arrow, first of all find the RN. Already I have given you the method. Then RN parallel with the RS will give you the value of output resistance. Right. Or second thing, if that is the diagram, last diagram, that is asked by what? Abid. If this is the question, this was the previous year question, here RS is connected. RS is connected, and what is the output resistance at this point? Or in this question only one thing is given, that is the GM. GM is given here, value of the RS is given here, and what is the R0? Very simple. What is the RN here? RN is nearly equal to what? 1 by GM. Find the 1 by GM, and what is the R0 then? R0 is nothing but RS parallel with what? 1 by GM. I think now this is clear to you. 2 marks question in GATE exam. That is the 2 marks question in GATE exam. RS parallel is 1 by GM. Finished? ये है another question without RD. ये भी देखो एक important question आ गया है. How we can find? ये भी एक question है. Right. Okay. Last one, on the base of this, there may be a Thevenin's theorem or so on. This is the question. This is the VI. Here we are taking the output RD. Now, if in this case the Thevenin's resistance is required, then what will be the value? If in this case the Thevenin's resistance is required, then what will be the value? Tell me. Now, in this case, we are taking the output from drain. So it is a common source configuration, common source with unbypassed RS. So that is the load. Actually, this is the load. Now we are calculating the Thevenin's across what load? Thevenin's across the load. Okay. So what parameters will be asked to find using the pi and RE model? Pi model and RE, which parameter? Gain, input resistance, output resistance. Normally mid-band voltage gain, input resistance, and what? Output resistance. Simple use of what? Network. Draw the model, use of network. Just I am giving same model. In case of pi model, same logic. For example, Thevenin's equivalent is required, Norton's equivalent is required. So this time RD is RL. So first of all make the model, and then question is what? Question from network only. For example, this is the GM VGS. Always draw the model like this. GM VGS. What is the resistor here? RD is given. Right, this is the drain terminal. What is connected here? RS is connected here. After connecting the RS, that is the ground. That is the common ground. Always make a common ground. This VI is connected between these 2 points. This is the gate. This VI is connected here. Right, here we have to connect what? RD. And this time RD is nothing but RL, or this voltage is called what? VGS. This is the terminal S, this is the VGS. This is clear to you everyone? No. If that is clear, or if the Thevenin's resistor is required, always remember we have to calculate the Thevenin's resistor at this point. Thevenin's or Norton's resistance at this point. Thevenin's or Norton's are equal. Then what is the method? simply remove RD, simply remove the RD, or in place of RD connect a 1 volt battery, 1 volt battery, and that is the I. Or make Vi is equal to what? 0. Make Vi is equal to what? 0. Then here the current GMVGS. So what is the current here? I minus GMVGS. What is the current here? Again I. Now write down the equation. It will become 0 is equal to VGS plus I into RS. So what is the VGS is equal to? Minus I into RS. Or remember this, RTH is nothing but 1 by I. It is the equation number 1, it is the equation number 2. Write down the 1 KVL in output loop. 1 KVL in output loop. It will become minus 1. This is the minus 1. Plus I into what? I minus GMVGS into what? RD into RD plus I into RS. I into RS is equal to 0. Who is the villain? GM is the villain, VGS is the villain. So what is the VGS? Minus I into RS. To put here, it will become I RD minus GM. When I am putting the VGS is equal to minus I into RS, so minus minus it will become plus RD RS into what? I. I'm just replacing the VGS by I into RS. Then plus IRS is equal to what? 1 volt. Then take I common, and what is the 1 by I? Tell me. So you will get RD plus RS 1 plus GMRD. That is the answer. RD plus RS 1 plus GMRD. That is the Thevenin's equivalent. Is it clear? ये देखो रे, this is the RD plus RS 1 plus GMRD. This is called the Thevenin's resistance if the question is given on what? Common source. This is the common source with source resistance RS. Now, if I am making the RS is equal to 0, it will act as short circuit. The output resistance will become what? RD only. The output resistance will become RD. If I am simply bypassing this, bypass capacitor is used, what is the output resistance? Simple RD, a simple small RD will be the output resistance. If the RS is not given, if the RS is bypassed, in both the cases the output resistance will be small RD. If it is not bypassed, then that is the formula. Or GMRD is called what? Mu, amplification factor. So I think that concept is clear to you everyone, how we can find the Thevenin's equivalent for that diagram. Okay, that is clear to you everyone. So this type of questions in conceptual question in GATE exam, तो okay then. तो आज के लिए इतना ही दोस्तों, फिर मिलेंगे. अभी फिर से अब आपके सेशन को मैं एक्स्ट्रा सेशन में ही अरेंज करना होगा. काफ़ी स्लाइड्स थी, लेकिन अब देखिए मैं आपको बता दूं जरा. In evening we have one session everyone. So there is a one session that is what Menti war between me and Ramesh sir from 9 PM. Please join that. Subscribe our channel so that you will get the notification about this session. Menti war, EDC or analog, and that is important for what? Electrical student and electronics student both, because in EDC we will cover what? Basic electronics, and in analog that is operational amplifier or what? Transistor, MOSFET, each and everything. And another session, complete revision of what? Complete formula for analog, exactly at 7 PM. 7 PM complete formula revision. Complete formula revision. Okay, already I have given the idea. RD means what? Small RD from early effect. VA by IDQ. Drain resistance VA by IDQ. Even particular numerical RD is not given, you can take it what? Infinite. Analog, right? और एक और सेशन जो नथिंग इम्पॉसिबल जो राकेश सर और अंकित सर का चल रहा है, नॉन स्टॉप मैथ्स होने वाला है फ्रॉम 29 जनवरी एट 11 AM, राइट? मैथ्स. और आज है वर्चुअल कैलकुलेटर पर एक बहुत ही शानदार सेशन होगा, आप लोग उसे ज़रूर अटेंड कीजिएगा. और आपको मैं बता दूं, एक नेटवर्क पर 30 क्वेश्चंस के साथ ट्यूसडे मिस मत कीजिएगा। अगर आपको लगता है कि नेटवर्क में से आपसे सब क्वेश्चन बनने चाहिए, इफ यू वांट टू गेट द कमांड ओवर ऑल कंप्लीट नेटवर्क, ट्यूसडे 30 क्वेश्चंस, 30 questions on what? Network. Right, and with this 30 questions you will get the command over what? Network. Each type of questions from each topic, 3 to 4 questions we will cover. What? Transient, first order, second order, two port network, right, and steady state analysis of the sinusoidal signal, locus diagram, KCL, KVL, mesh nodal analysis, super mesh, super nodal analysis, theorem, Thevenin's, Norton's, maximum power transfer theorem, right, and initial condition, questions on initial conditions. So that is on Tuesday, 30 questions on network. If you want the notification, then simply subscribe the channel, like the session and share the link of this session. Okay, then this is our channel. Subscribe this, a complete solution to all your GATE problems. And you are on BYJU'S Exam Prep. Thank you for attending the session. Thank you and good day and good luck for coming exams. Thank you.